I now request our Honorable Vice Chancellor, Professor G.P. Rajshekhar, to kindly come on to the dais and occupy his chair. May I now request the presiding officer, Dr. C.H. Mohan Rao Garu, former Director, CCMB and Chairman, SAC, ASTC. Dr. D. Raghunath Rao Garu, Founder, Director, Homi Baba Cancer Hospital. Professor D.N. Reddy, former Chairman, RAC, DRDO and Vice Chancellor, JNTU, Hyderabad. Professor C.S.R.K. Prasad Garu, Vice Chancellor, JNTU, Kakinada. Professor G. Narahari Sastry, IIT Hyderabad, former Director, CSIR, NET, Johar. Professor B.S. Murthy, Director, IIT Hyderabad. The guest of honor, Dr. Prakash Chauhan, Director, NRSC, Hyderabad. The guest of honor, Dr. Mrutyunjay Mahapatra, Director General, IMD, Government of India. Ladies and gentlemen, I request all of you to kindly stand up and put your hands together as I invite Padma Shri Professor Sangamitra Bandyopadhyaya, Director, IISc, Kolkata. Madam, it's a privilege for all of us to have you here. Thank you, sir. As we begin today's proceedings, let us seek the blessings of Almighty. I invite the Department of Music, students from the Department of Music, to sing the Andhra University song for all of us. Come fast.
Vandanam Abhivandanam Vandanam Abhivandanam Vandanam Subhavandanam Andhra Vishwakalamatalliki Akhila Sastra Vikasa Murti Andhra Vishwakalamatalliki Akhila Sastra Vikasa Murtiki Vandanam Abhivandanam Subhavandanam Vandanam Abhivandanam Subhavandanam చదువు తల్లికి మేడగట్టిన మహాపురుషులు తత్వవేత్తలు చదువు తల్లికి మేడగట్టిన మహాపురుషులు తత్వవేత్తలు కట్టమంచి రాధాకృష్ణులు ఎంచి పెంచిన మంచి వనమిది కట్టమంచి రాధాకృష్ణులు ఎంచి పెంచిన మంచి వనమిది వందనం అభివందనం శుభవందనం సరస సద్గుణ శారదాంబకు పూజ సల్పిన పుణ్యమూర్తులు సరస సద్గుణ శారదాంబకు పూజ సల్పిన పుణ్యమూర్తులు ఎందరో ఆచార్యవర్యులకందరికి మా వందనం ఎందరో ఆచార్యవర్యులకందరికి మా వందనం వందనం అభివందనం శుభవందనం భారత భారతావని ఖ్యాతి చెందగ మాతృభూమికి సేవ చేయగ భారతావని ఖ్యాతి చెందగ మాతృభూమికి సేవ చేయగ వినయభూషణ కాంతుల మరగ తరలిపోయిన తరుణ యువత వినయభూషణ కాంతుల మరగ తరలిపోయిన తరుణ యువతకు వందనం అభివందనం శుభవందనం పరమ పావన దీవిసాలుర కందరికి మా వందనం ఆంధ్ర విశ్వకళామ తల్లికి అఖిల శాస్త్ర వికాసమూర్తికి వందనం అభివందనం శుభవందనం వందనం అభివందనం శుభవందనం అభివందనం శుభవందనం అభివందనం శుభవందనం ధన్యవాదాలు.
Thank you. May I now invite all the dignitaries to offer floral tribute to the great teacher, Bharat Ratna Dr. Sarvepalli Radhakrishna, and then proceed to the ceremonial lighting of the lamp.
महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दित महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दित महागणपतिम् महादेवसुतं गुहनुतं महादेवसुतं गुरुगुहनुतं मारकोटि प्रकाशं शान्तं महादेवसुतं गुरुगुहनुतं मारकोटि प्रकाशं शान्तं महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकाप्रियं महाकाव्यनाटकादिप्रियं मूषिकवाहनमोदकाप्रियं महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दित महागणपतिम्
May I now invite our Honorable Vice Chancellor, Professor G.P. Rajshekhar, to kindly deliver the welcome address.
Subhodayam. Good morning, everyone. Respected dignitaries, esteemed colleagues, dear students, and all the guests here today. It's a great privilege to welcome you all to this important conclave organized by Andhra University in collaboration with the Academy of Science, Technology and Communication, Hyderabad. We are gathered here at a pivotal moment in the history of higher education in India, where significant reforms of higher education happening across the country. All the education institutions are witnessing the same. We have a greater responsibility to respond to these reforms and take the institutions, take the youth forward. Today we commemorate the birth anniversary of Dr. Sarvepalli Radhakrishnan, a distinguished scholar, philosopher, and former President of India, whose dedication of education has left an indelible mark on our nation, who also served as the second Vice Chancellor of this Andhra Viswakala Parishad. Dr. Radhakrishnan believed that teachers should be the best minds of the country, and it is our responsibility to live up to that vision. Taking his message forward, we are gathered here. We are honored to have such a distinguished guest with us today. It's a privilege that all of us have kindly agreed to be here. Our keynote speaker, Padma Shri Dr. Sangamitra Bandyopadhyay, Director of the Indian Statistical Institute, Kolkata, is a luminary in computational biology, machine learning and pattern recognition, and she is the first woman to lead the Indian Statistical Institute. Thank you, madam, for being here. We are also privileged to have with us Dr. Mrityunjay Mahapatra, Director General of the Indian Meteorological Department, IMD, known as the Cyclone Man of India. He is a renowned meteorologist whose expertise in tropical cyclones and weather forecasting has saved countless lives. Thank you very much for being with us, sir. We welcome Dr. Prakash Chauhan, Director of the National Remote Sensing Center, NRSC, Hyderabad. He is a leading space scientist with significant contributions to planetary remote sensing, including pioneering work on Indian planetary missions like Chandrayaan-1 and Chandrayaan-2. Thank you very much, sir, for being with us. Our gathering is further strengthened by the presence of our good friend, very humble person, known for his simplicity, Professor B.S. Murthy, Director of IIT Hyderabad, a respected figure in the field of metallurgical and materials engineering. Thank you very much, sir, for being with us. We also welcome Professor D.N. Reddy, former chairman of RAC DRDO and former vice chancellor of JNTU, who is known for his leadership in the field of education. And I welcome with privilege Professor C.S.R.K. Prasad, professor of NIT Warangal and current vice chancellor of JNTU, an expert in civil transportation engineering. Thank you very much, sir, for being with us. Rounding out our list of distinguished attendees, we have Professor G. Narahara Sastry of IIT Hyderabad, a pioneer in computational chemistry and drug discovery, who was kind enough to spend with us, though he gave an endowment lecture yesterday in our department. He is kind enough to extend his stay and stay with us. Thank you very much, sir. And we have with us Dr. D. Raghunath Rao, founder director of Homi Baba Cancer Hospital, leading medical oncologist. Thank you very much, sir. And we would like to also honor the presence of my good friend, Dr. V.M. Chaudhary, Group Director at NRSC ISRO, a specialist in geospatial applications of water resource. And we have dignitaries from IMD, also NRSC with us, witnessing a milestone in the history of Andhra University, where we'll be signing 2 MOUs. Thank you very much, all of us, for being with us. It will be unfair if I do not mention one name, that is Professor C.L. Narasimha Rao Garu, Science, Technology, Communication. He has nurtured the art of communicating science. So thank you very much. Because of his drive, we are having this today. And we have Dr. C.H. Mohan Rao Garu, Chairman SAC, ASTC, former Director, CCMB. So who is also instrumental in bringing this very event to Andhra University. Today's conclave is an ideal platform to share insights, collaborate across fields, and define a path forward that fulfills the aspirations of our students and the needs of our nation. I urge all participants to engage deeply and interact with the scientific leaders who are very simple, down to earth, and who are willing to interact and take your thoughts forward. Our country is undergoing a remarkable transformation where we have National Education Policy 2020 in place. So it's our duty to respond and take the vision of NEP forward. So which is loud and clear, talking about reshaping education to be holistic, multidisciplinary, and joyful, engaging. So it seeks to empower every student with critical thinking, creativity, and global perspective while staying deeply rooted in our cultural values and Indian knowledge systems. As academicians and learners, we carry the responsibility to equip our students with the ability to contribute meaningfully to the society. So our curricula designed in alignment with NEP 2020 reflect a commitment, provide education that is very not just informative, also transformative, and ignites passion among students. Andhra Pradesh, our home, is on the threshold of a new dawn with the vision of Swarnandhra, the Golden Andhra, and Viksit Bharat, a developed India. So the vision of Swarnandhra is very much aligned with the themes of Viksit Bharat 2047. One of the key verticals is Technology Vision 2047, where all of us are pledging the scientific community to become technology independence, which means when we got independence in 1947, we would like to aim to achieve technology independence by 2047, so that if not 100%, at least to majority of the percent to be indigenous. Achieving this vision demands dedicated efforts across all fields of science, technology, communication, and beyond. So it calls for the integration of knowledge and skills and relevant transformatives. So this is a time to awaken young minds, to inspire them, guide them towards an integrated approach, learning and innovation. A time when experts across core sectors must come together to build a strong nation. So this conclave is an attempt to remind us of the great contributions done by our past leaders and the present leaders of science and technology. This indeed truly ignites the current festive atmosphere at Andhra University while we are celebrating the centenary year of Andhra University. So this very Andhra Visvakala Parishad is celebrating the 100 years. We have kick-started the curtain riser on 26th April 2025 and we are moving forward, marching forward to have a grand occasion on 26th April 2026. So with this, in an attempt to respect the contributions of all those who had dedicated their lives for the development of the nation, development of this institute, we say century of excellence paving the path for the future. So we have visioned across three verticals, namely academic, infrastructure, and outreach. So with this vision, we are moving forward. So we have planned year-long activities which are scheduled for coming months. So we are determined to take these celebrations into a truly festive mood. We are very happy to see that the university has done well in the NIRF ranking 2025. It has improved in 4 categories of the 6, standing at the 4th university in the country among the state-funded university, but we are not satisfied. The dream is big. I sincerely appeal to the scientific leaders here to support us in this journey, collaborate with us in any manner that they can. We will be specific, we will be approaching you with specific appeals. My earnest appeal to kindly support us. Let us pledge to be torchbearers of this new educational era and partners in the journey towards Swarnandhra Viksit Bharat. Thank you once again for all the dignitaries for making their time out of their busy schedules and being with us. And I thank all the eminent personalities, retired teachers, executive members of Andhra University, deans, principals of Andhra University, heads of the departments, faculty members, research students, dear students, for making it to be. Please have active participation and make this event fruitful. Thank you once again. Jai Hind.
Thank you, sir. I now request Shri C.L. Narasimha Rao, Secretary ASTS, to introduce the guests to the august audience.
Respected dignitaries and invitees, a warm and cordial welcome to all of you to this Science Conclave on Science Technology Frontiers for Swarnandhra and Viksit Bharat 2047. Andhra University enters its centenary as a proud fortress of wisdom, nurtured by visionary leaders and successive vice chancellors. On behalf of Andhra University and ASTC, I extend greetings to all the teaching community of Andhra Pradesh and our distinguished speakers, present and former vice chancellors, faculty members, scientists, academia and industry, research scholars, and all the senior academicians participating in this conclave. At the outset, I thank Professor Rajsekhar Garu, our Honorable Vice Chancellor of Andhra University, for graciously accepting our request to join hands with Andhra University in holding this science conclave, bringing together a galaxy of distinguished scientists. I extend my grateful thanks to him for making this science conclave to motivate the academic community and also for providing an opportunity to the research scholars to interact with the eminent speakers. On this historic day, which also marks the Teachers' Day and the 50th death anniversary of Bharat Ratna Sarvepalli Radhakrishnan, we pay a golden year tribute to his timeless ideals and of scholarship and service. We are deeply honored to have as our chief guest Padma Shri Dr. Sangamitra Bandyopadhyay ji, Director of the Indian Statistical Institute, Calcutta, a distinguished scientist. Presiding over today's function is Dr. C. Mohan Rao Garu, Chairman of the Scientific Advisory Council of ASTC, former Director of CCMB, and presently eminent professor at BITS Hyderabad. We are equally privileged to welcome our guests of honor, Dr. Mrutyunjay Mahapatra ji, Director General of the Indian Meteorological Department, IMD, and Dr. Prakash Chauhan ji, Director, National Remote Sensing Center, Hyderabad, for their kind participation in spite of their very busy schedules. As Secretary of ASTC, I would like to briefly highlight our recent activities. ASTC has consistently advanced the cause of self-reliance and innovation through impactful symposiums and lectures. I will briefly mention that during the pandemic, we have hosted the Electronics for Self-Reliance with the CSIR and DRDO leadership, followed by recent trends in space sector, New India, with the former ISRO Chairman Secretary MOES. We celebrated women scientists through the Women Scientist Conclave, inaugurated by the then Governor of Telangana, Dr. Tamilisai Soundararajan. The recent flagship event of ASTC annual convention featured Padma Bhushan Dr. Nageswara Garu delivering the Foundation Day lecture on the gut microbiome. Our national technology celebrations, Honorable Governor Sri Jishnudev Verma ji, Governor of Telangana, released the ASTC communication booklets and presented Science Popularization, Excellence and Lifetime Achievement Awards. More recently, we had our ASTC organized this National Space Day at Vijnan, Guntur. Coming to our chief guest today, Professor Sangamitra Bandyopadhyay ji, Director of Indian Statistical Institute, is one of the most distinguished luminaries of Indian science. I am just taking more time, sir, because from AST side also I have to add. So, honored with the prestigious Santeshwari Bhatnagar Award, Padma Shri Award from Government of India, Infosys Prize, and J.C. Bose Fellowship, and many others. She is a pioneer in artificial intelligence, machine learning, and computational biology with over 200 international publications. The first woman director of the Indian Statistical Institute. She is also a fellow of IEE and TWAS and all major Indian science academies like Indian National Science Academy, Indian Academy of Sciences, National Academy of Sciences, Allahabad, INA, Indian National Institute, Academy of Engineering, as well as member of the Prime Minister's Scientific Advisory Council. At this juncture, we also recall with pride the illustrious contributions of Dr. C.R. Rao. C.R. Rao garu is an alumnus of this Andhra University and former director of Indian Statistical Institute, who brought global recognition to Indian science. Our guest of honor, Dr. Mrityunjay Mahapatraji, Director General of the Indian Meteorological Department, IMD, has devoted more than 3 decades to weather forecasting, cyclone warning and disaster risk reduction. Under his leadership, India's cyclone forecasts have achieved world-class accuracy, saving countless lives. His contributions include 120 research publications and global leadership roles, and his prestigious awards, most recently the United Nations Saskava Award for the Disaster Risk Reduction in 2025. He serves as India's permanent representative to the World Meteorological Organization. In honor of Panchet Kotiswaram, the pioneer of Indian meteorology, it is most fitting that Mahapatraji delivers today's memorial lecture. Here, Professor Kotiswaram garu, born in Nellore in 1915, with a was a visionary scientist who transformed India's meteorological services. As Director General during 1969-75, he modernized cyclone warning systems, strengthened disaster preparedness, and represented India with distinction on the global stage. At the cyclone after 1977, we had a program at Cyclones Disaster Management at Jubilee Hall in Hyderabad, wherein Dr. Kotiswaram was felicitated by the then Chief Minister of Andhra Pradesh, Dr. Marichanna Reddy garu. So, recipient of Padma Bhushan, Professor Kotiswaram is remembered as the founding president of the Indian Meteorological Society. Professor Kotiswaram garu laid the foundations of modern meteorology in India. So, it is most fitting for Mahapatraji, whose work today protects millions, carries forward his proud tradition. We are going to hear him after the presidential address. Our guest of honor, Dr. Prakash Chauhanji, Director of National Remote Sensing Center. He has been a source of inspiration for all of us at ASTC, and he has been rendering distinguished service in ISRO for over 3 decades, beginning in the Space Application Center. His pioneering work in planetary remote sensing placed India on the global map. As principal investigator on Chandrayaan 1 and 2, his team conclusively detected water molecules on the moon, a discovery of historic importance. His earth science research scans ocean colors, aerosols, climate and disaster risk management. Recipient of several awards and with more than 150 publications, he serves on global UN committees. His leadership at NRSA ISRO continues to expand India's frontiers in space science and earth observation, besides fostering an enduring culture of scientific excellence. Our presiding dignitary, Dr. C.H. Mohan Rao garu, CSR Distinguished Scientist and Fellow of the 3 National Academies and recipient of Shanti Swarup Bhatnagar Award, has made landmark contributions in molecular biology and biophysics, including DNA-based diagnostic chips and smart nanoparticle therapies. Beyond his science, he is a passionate science communicator who inspires the young minds. ASTC is deeply privileged to have his blessings and leadership as chairman of its Scientific Advisory Council. Dr. D. Raghunath Rao garu, Vice Chairman of Scientific Advisory Council, ASTC, a renowned personality in medical sciences and an eminent oncologist, recipient of the prestigious B.C. Roy Award and founder director of the Homi Baba Cancer Hospital, Visakhapatnam. He is going to deliver the Dr. Ella Pragat Subbarao Memorial Lecture today. Dr. D. N. Reddy garu, former Vice Chancellor of JNTU Hyderabad and former Chairman of the Research and Assessment Center of the DRDO, with over 4 decades of professional experience in higher and technical education. He also contributed to the Office of the National Cyber Security at PMO and served as Director of the C.R. Rao Research Institute at Hyderabad. Professor B.S. Murthy garu, Director of IIT Hyderabad, is a distinguished metallurgist and an eminent material scientist in the country, and Shanti Swarup Bhatnagar Awardee with high publication record, elected fellow of all major national academies, will deliver Professor Sir Bhagavantam Memorial Lecture. It is very difficult for me to highlight the contributions of these people within this short time. However, I take this opportunity to briefly highlight Professor Sir Bhagavantam, former principal of the Science College of this university and was also president of the Andhra Pradesh Academy of Sciences. A respected personality in Indian science, And we fondly recall his association with Andhra University, especially on 28th February 1988, during the Diamond Jubilee of the Raman Effect and Sir C.V. Raman Centenary celebrations. At that time, Professor V. Lakshmi Narayana was the principal of the Science College. Again, he is a student of Swami Jnanananda. He was, and Professor K.V. Ramana garu was the Vice Chancellor. As Professor Bhagavantam was facing some health, facing age-related issues, neurological issues, his son, Professor Suri Radhakrishna, Professor of Physics at IIT Chennai, requested me to accompany him to the centenary celebrations. Professor Bhagavantam fondly revisited the physics department, pointing out his own room and also that of Sarvepalli Radhakrishnan's room. He also delivered a memorable speech along with Professor R.S. Krishnan, another associate of Dr. C.V. Raman, at the Assembly Hall. So that occasion was almost his last academic appearance. He passed away on 6th February 1989 after about 11 months. It is really a right place to Professor Murthy garu, B.S. Murthy garu, to deliver Professor Bhagavantam Memorial Lecture on this occasion. Professor CSRK Prasad garu, presently Vice Chancellor of the Jawaharlal Nehru Technological University, Kakinada, obtained all 3 engineering colleges from REC Warangal with 37 years of vast teaching and research experience at NIT Warangal and over 150 publications, and executed several research projects. He will enrich our deliberations today. Professor Dr. G. Narahar Shastri garu, he is currently professor at the Department of Biotechnology at IIT Hyderabad. He earlier worked for 2 decades in the molecular modeling division of the CSR IICT and later served as director of CSR NIST, Jorhat, Assam. A recipient of several awards, including Shanti Swarup Bhattacharya Prize. He has authored more than 340 research papers and is an elected fellow of all major national academies. He was closely associated with Dr. K.V. Raghavan, the former director of IICT, former president of the Andhra Pradesh Academy of Sciences, and chairman of RSC DRDO. Professor Shastri will be delivering Dr. K.V. Raghavan Memorial Lecture in this afternoon. We are also grateful to the scientists and professors attending this conclave, particularly those who have travelled from long distances, such as Dr. C.H. Venkateswara garu, Additional Director General of GSI. Your presence is a source of encouragement and inspiration to the organizers. I again express my grateful thanks to Professor Rajsekar garu, Registrar of the University, Professor Rambabu garu, and ably assisted by the Dean Outreach, Ramasudha garu, and her efficient research scholars team. Dignitaries, ladies and gentlemen, with youthful vigor and renewed excellence, the university now sets its course towards the aspirations of the Swarnandhra as envisioned by the Honorable Chief Minister of Andhra Pradesh in alignment with the national mission of Viksit Bharat 2047 led by the Honorable Prime Minister of India. Let this centenary occasion be a moment to honor our past, celebrate the present, and envision a bright future. With this I conclude. Thank you all.
Thank you, sir. I now request Dr. C.H. Mohan Rao garu, Chairman, SAC and ASTC, to give the presidential address. And I hand over the proceedings to the president of today's function, C.H. Mohan Rao garu, and Professor G.P. Rajshekar garu.
Dignitaries on the dais. As you can see, there's a large number of dignitaries. Just now the introductions were going on. Everybody is a national figure, international figures as well, and contributed to the science and technology growth of our country. At the outset, I would like to wish all of you a happy Teachers' Day, particularly being held in Andhra Pradesh, held in Andhra University. I was noticing when I came into the campus that you call this as a Andhra Vishwa Kala Parishad, in contrast to Andhra Vishwavidyalayam. It would have been in other places we call university as a Vishwavidyalaya, but here you call it as a Vishwa Kala Parishad. It was an interesting experience for me to notice that. This university now is celebrating centenary here. The Academy for Science, Technology and Communication, ASTC, just now Narasimha Rao has introduced to you, is happy and proud to co-organize this event with the University of Andhra University, and particularly on the Teachers' Day, and more importantly because Dr. Sarvepalli Radhakrishnan, a great philosopher, was the Vice Chancellor of this university. Very, very nice to see that. And I also see that Professor Rajshekhar was mentioning about the past of the university and the future, where he envisions taking these universities to the very high levels and following with the new education policy of the government, and see how we can contribute to the growth of the country. And Professor Rajshekhar Garu, we all will be here, as much as we could, we will be happy to help you out wherever possible. This conclave is titled Science, Technology for Viksit Bharat and Swarnandhra. Would science and technology actually make Viksit Bharat? Is that possible? What will science do to make country Viksit Bharat? Yes, most certainly. Most certainly science and technology is the only thing that can make any change. Science is a proven tool of social transformation. If you want to see the evidence, you can compare India of 1947 with India of 2025. In 1947, average life expectancy of human beings in India was 37 years. Now, 2025, it has gone to 72 years. Okay. So, significant increase in the average expectancy. Literacy rate was 12% in 1947, now it is 74%. Child mortality was 189 per thousand, now it is 27 per thousand. A country with the insufficiency of food at the time, we were getting food from different countries at the time, now became a food exporting country. Our success in space and defense technologies is remarkable. Recently, we have seen Operation Sindhur that showcased our innovative technological acumen. In addition to buying equipment from other people, our scientists have introduced AI into them and succeeded to demonstrate to the world that our technological acumenship is no less than anybody in the world. Covaxin, our vaccine developed by Bharat Biotech in India, is a proud of our country. When all the nations were suffering, India could make its own vaccine. Although a large number of academicians, including scientific organizations, were very skeptical, doubtful, and expressed openly the possibility of developing a vaccine, but India demonstrated producing vaccine very effectively. And I'm sure you must have heard that later studies showed that the vaccine that India made was much better compared to any other vaccine. And electronics and communication, information technology are advancing, leading our country to become a developed nation. So there is no doubt that science and technology, in fact, science and technology alone, would be helpful to convert our country into Viksit Bharat and state into Swarnandhra. At this occasion, since Rajshekhar also pointed out, I would like to say that our university should perhaps start translating or transforming into entrepreneurial universities. Not just teaching universities, we should become entrepreneurial universities where the universities will produce technology and make money out of the technologies that they produce and sustain themselves. So they must be entrepreneurial universities. We should train social entrepreneurs and science and technology entrepreneurs as well. Key factors that we should be paying attention to should be probably innovation and values. Okay. If you look at values, actually right now in the country is that there are many people with the knowledge but without values. Okay. Now, values are very critical for actually succeeding. Maybe university can have a cultural center, one that might be useful. We should encourage transdisciplinary discourse on social problems. This might help develop togetherness, tolerance, and sense of belonging to the nation. That sense of belonging to the nation is important in addition to having knowledge. Innovation is a key for any social transformation. India has been a knowledge society and we were ahead of rest of the world in many areas. For example, mathematics, astronomy, metallurgy, medicine, economics probably, and many areas. We need to build and nourish innovative ecosystem in the campuses. Okay? Setting up a university innovation center, not for the namesake, but a functional innovation center should be set up. In my opinion, innovation center should have two components. One is that where companies can come, students, who has an idea can start a company, float a company, do all these things. That's a routine thing that we do. In addition, there must have a place where a student has a crazy idea, must be able to test it. Test the crazy idea before it goes anywhere else. So you must have a place where crazy ideas can be tested. That means that you must have facilities at one place which with full access to all young students so that they can fool around and find out something new. Let us look at research and teaching components. You must recruit the very high quality faculty. Try to avoid inbreeding. Inbreeding is one of the things which is killing our universities. And we should develop infrastructure, very high quality, global level infrastructure. That infrastructure not only helps you to do research, but also earns money. You can lend the machines to other people to use, and then you can generate money in which you can use. And also innovation centers will also, you take a stake and you can again make money out of these things. That will be very, very useful. What are the areas? Of course, here Professor B.S. Murthy, others are there. They will talk about it, and our chief guest herself. Many other people are there. They will be talking about current areas. But what are the current areas that we are now going to talk about? One is the AI, artificial intelligence. Long time ago, if people who do not speak English were at disadvantage, you don't know English, then you are really nowhere else. You can't go anywhere else. Little later, computer knowledge. If you cannot use computers, you just nowhere else. You must use computers. You must be knowing computers. Now and today, tomorrow, if you don't know AI, you are nowhere. Okay? So AI has to be part of your life anyway. So now we have to start teaching AI. Everybody talks about AI. Most of it is just baloney. Okay? Many people, they say, based on AI technology, there is no AI technology. They're just simple algorithmic processes. Real AI used in very few places, and we need to understand what exactly AI, what it will do and things like that. So that must be taught. Practical aspects of it must be taught. I think university should really pay very big attention onto that, AI, ML, things like that. And AI in biomedical application is a separate ball game altogether. Okay? AI in biomedical applications will become important, and we should start paying attention to that. For example, imaging. Imaging AI is very, very effectively useful. And drug design also, I'm sure Narayana Shastri would touch upon AI in drug designing. Quantum computing. Quantum computing is now becoming a fantastic area of it. Now many people seem to think that quantum computer will be much, much faster than other computers that we have. We are going to jump in the speed. No, quantum computers are not going to be faster. Quantum computers will not do anything faster than if you are doing word processing or PowerPoint presentation, quantum computer will do nothing. In fact, might be even slower. Quantum computer will only work when you have a massive data, mass possibilities, probabilities are there. You want to find one solution for that. For example, people who know biology, protein folding, a protein can adopt millions and millions of conformations. So only one conformation is correct. How will you know which conformation is correct? Now we do sequential computation, which takes long time. Now if you use AI, now if you use quantum computation, that must be possible to do it in very, very quick way. That is another way of quantum communication. Very recently, I had a chat with Dr. Sood, our advisor to Government of India, and I was asking between quantum computation and quantum communication, in which area India is likely to make a breakthrough, or at least stand with the other nations of the world. He thinks quantum communication. Quantum computation, maybe we will not make it, but quantum communication, we probably would make it. And nanotechnology, CRISPR-Cas technology for food and healthcare industry is very important to generate. And cell-based therapies. All these years we are using chemicals, drugs. Some other drug we are using, chemical drugs. Most of the chemical drugs are inhibitors. Start with, if you have blood pressure, calcium channel inhibitor, beta blocker. If you have acidity, proton pump inhibitor. You have anything, some inhibitor is there for it. Okay? Now this inhibitor technology will change, and we are now going to use cell-based technologies. You use cells, treat the cells, convert the cells into what they want, what you need to do them, and put the cells back. So cell-based therapy is going to be there. Nanosensors, wearables, body, all over the body you can have sensors, green chemistry, And all these things are possible. And in addition, India has a large traditional knowledge, and we should be able to strengthen that traditional knowledge as well. And teaching also is likely to change because students don't come to classes nowadays. There's no need for them to come to classes because there's a YouTube and there are other ways. So now we should also change a digital presence, how we can improve teaching and communication using digital ideas. That's, I think, one of the ideas that we should start inculcating and train students to ask major questions and think big, contribute to creation of the knowledge to the country. That's very, very critical for us to do it now at this juncture. And also the students, particularly the younger ones, if they have an idea, if they want to start a company, float a startup company, where do you go? What are the procedures? Who are the regulators? We have so many rules and regulations. So we must also have a place where we can teach or provide access to all the younger people to start. If you want to start a company, what to do about it. Okay. So success in innovation is built upon curiosity, critical thinking, and ability to connect ideas across the disciplines. Now, today we have a series of lectures by outstanding people. Dr. Sangamitra Bandyopadhyay herself is an AI expert. Professor B.S. Murthy, Professor Narahari Shastri, Dr. V.M. Chaudhary, Dr. Mahapatra, Dr. Raghunath Rao. I'm sure lectures by all these people will be highly inspiring, and I'm sure younger people here will take leads from here and develop your careers, at the same time develop Andhra Pradesh and develop India. Thank you very much. May I take this opportunity now to invite Dr. Mrityunjay Mahapatra, Director General of IMD, to deliver Padma Bhushan Dr. K.P. Koteshwaram Memorial Lecture. Please.
Remote. I have a presentation.
Okay.
Namaskar, good morning to all of you. Honorable Vice Chancellor, Andhra University, Professor G.P. Rajsekhar, Honorable Chief Guest of this function, Professor Sangamitra Bandyopadhyay, Director, Indian Statistical Institute, Professor Mohan Rao, Chairman, SAC ASTC and former Director, CCMB, Dr. Prakash Chauhan, Director, NRSC, Hyderabad, distinguished guests on the dais, distinguished faculties, students, researchers, former faculties, ladies and gentlemen. At the outset, I express my deep gratitude to Honorable Vice Chancellor, Andhra University, and the team for providing me an opportunity to be associated with this august occasion. I take this opportunity to express my highest tribute to Dr. Sarvapalli Radhakrishnan on this Teachers' Day. I also wish all of you a happy Teachers' Day. And this Science Conclave is a symbolic initiative on this auspicious day to acquire knowledge and spread knowledge among ourselves, and hence to empower each of us in the society. Dr. P. Koteshwaram was the former Director General of Meteorology, India Meteorological Department. He has been introduced by the Secretary, ASTC, Professor Narasimha Rao. I just want to add one or 2 points. Whatever we say, that will be insufficient to introduce Dr. P. Koteshwaram, Padma Bhushan. His contribution is noteworthy in various fields of meteorology, and allied sciences. He led India in international fora. He was the first elected vice president of World Meteorological Organization, bringing the India the glory. I want to mention here that he also experienced in Nellore a very destructive cyclone in his childhood. And when, after completion of his PhD, he joined India Meteorological Department, his research started with cyclones. He was posted as the head of Cyclone Warning Center, Kolkata. And all of us know that the first cyclone warning system started in Kolkata port in 1865. And therefore, it was a very good ground for research, and he took advantage of that and extended the understanding of the science of cyclones apart from other fields of meteorology. He was also an expert in the science of monsoon. His major contribution towards the monsoon circulation is the establishment of the theory of tropical easterly jet, which is one of the 6 important components of the monsoon or Indian monsoon. So while I was told to deliver a lecture, I thought I am not such a person to deliver, but however I tried to find out the gist of the contemporary world. As all of us know that everybody, whether he is a small farmer or whether he is a very highly positioned disaster manager or policy maker, everybody is worried about the climate change. And one of the most important impact of the climate change is the weather and climate related disasters. Many of us who feel that the frequency, duration, intensity of disasters are increasing because of the climate change. So therefore, we should be prepared to meet the challenges. And where does the India stand at present? So therefore, I will be talking about for some time the India's early warning system in view of the climate change. So can I change here? So all of us know that the weather or climate is a byproduct of the various interactions occurring in this earth. There are various spheres around us. We have the lithosphere, the solid earth. We have got the atmosphere. We have got the cryosphere with the oceans and ice, etc., and the hydrosphere. And of course, we have got the biospheres. And there are various activities occurring in each sphere, and these activities are not limited to its own sphere. So there is interaction among the spheres and also within the sphere itself. As a result of this, we get or experience a rapid change in weather from one second to other second, and also there is a change in the climate. So when you look at the various causes of these natural changes or the natural causes of the variability of this weather and climate, there are various types of external forcings. Say, for example, the greenhouse gases. All of us know that greenhouse gas is bad, but it is a necessary evil. There is greenhouse gas, therefore we are existing in the surface of the earth. But however, the excessive production of the greenhouse gases has led us to a situation where now we are worried about this atmosphere. Then orbital variations of the earth around the sun, the solar outputs, volcanoes, plate tectonics, and there are other mechanisms which are contributing towards the natural variations of the climate. But the most worrisome is that apart from all these natural variations because of the interaction among the different spheres, we have added a new sphere to our climate system, that is the anthroposphere, that is the contribution of the human beings towards the destabilizing the balance in the atmosphere, in the ocean, in the earth, and the entire ecosystem, you can say. So these man-made activities are popularly called as anthropogenic activities, which is leading to increase in greenhouse gas concentrations and hence the global warming or the climate change. So this interaction is not limited only to the atmosphere, but all spheres are being affected because of this rise in temperature or the climate change. Now, if you just look at the anthropogenic causes, you will find that there are various causes of this artificial change in the climate because of the rise in temperature due to man-made activities. And the topmost one is the coal or the industry. And of course, there are other greenhouse gases, air pollutions, industrial processes, which are deforestation, etc. So if you just look at the atmospheric concentration among the various gases, the carbon dioxide is increased by about 36% over the past 250 years. So more than 60% of these increased in the last 50 years. So that means there is a rapid enhanced increase in the carbon dioxide and other anthropogenic gases because of the man-made activities. Now, if you just look at the global warming as a result, because of the rise in greenhouse gas concentration, you'll find that, yes, after the industrial era, that is from since 1850, we have started increasing the greenhouse gas in the atmosphere because of the man-made activities. But if you look at 1970 onwards, there has been rapid increase in the concentration of the greenhouse gases. There is exponential increase, you can say. And as a result, there has been the warmest year last year in 2024 is 1.51 degrees Celsius. So it is just not imaginable. The people thought that we will be reaching about 1.5 degrees Celsius towards the end of 2100. Then it was revised that it will be by perhaps 2050. But perhaps now the world leaders are thinking that it may not wait up to 2050. Before that also we may reach to 1.5 degrees Celsius. So due to this rise, it is not limited only to the rise in temperature, means the heat wave conditions or duration of heat wave or the intensity of heat wave, but it has got repercussions to entire world in terms of not only the extreme weather, but also other ecosystems and socioeconomic activities. Now let us look at its impact in different conditions, such as northern hemisphere or southern hemisphere. So rise is more serious in northern hemisphere because of the more land surface. Similarly, if you look at the land surface and ocean surface, there is also rise in land surface more compared to the ocean surface, but we should not be complacent that temperature rise is less over ocean surface because the heat capacity of water is 1. It can retain the heat. So therefore, we should worry. And as all of us know that some people also feel that carbon dioxide is being absorbed by the water in the ocean, therefore ocean is helping us, but that is not true. Because the increase in carbon dioxide, the acidity of the ocean is increasing, it is helping or it is destroying the various aquatic life, and which is also providing the food, energy to all of us. So what I was telling that all this impact has been quite serious since 1970s. Now people think always there are two different groups. People say that yes, climate change is not anthropogenic phenomena. So to prove that, this is a slide which shows that yes, it is not the sun, it is the human being which is contributing towards the rise in temperature. If you consider the variation of sun, it is the phase of solar dimming. So temperature should fall and it is falling, but on the other hand, the temperature is rising. That means we are going against the natural variation which is caused by the ultimate source of energy, that is the sun. Now, when we think about all these things, the climate change aspect, it is monitored globally by World Meteorological Organizations, and we have got Intergovernmental Panel on Climate Change. And WMO provides the scientific statement, especially towards the science of climate change, which includes the detection and then predictions. And for example, in India, we provide the detection of the climate change aspects, and we also discuss about the attributions and also provide the projections. There is no prediction in terms of the climate change. And for this purpose, Minister of Oceans works towards the direction, and every year provide a statement to WMO, and it goes to IPCC through Minister of Environment, Forest and Climate Change. But to measure all these impacts, there are certain parameters. And for this purpose, we go on monitoring continuously the earth, ocean and atmosphere with a set of observational network. It is land-based observations, space-based observations and atmospheric observations. And remotely sensed observations like the satellites play a dominant role because all of us know that it is surrounded by water and also the many hilly ranges. So if you look at the indicators, you find that yes, there are various types of glaciers which is melting, and you have got temperature over the land which is rising, and snow is melting. And you have got permafrost which is also decreasing, which is considered as sink, that is also decreasing. And you have got sea surface temperature rising. And like that, there are many other parameters which all of us know that humidity of the atmosphere is also rising. For 1 degree rise in temperature, humidity is increasing by about 7%. So therefore, with the same heat wave condition, for example, the discomfort which we are feeling today, because of the rise in temperature by 1 degree Celsius, the discomfort becomes more. So therefore, now we have started to provide you forecast of the humidity index instead of giving only temperature forecast. So like that, there are various parameters, and all these climatic parameters are considered while defining or estimating the impact of the climate change. So now these are some of the indicators what I have discussed so far. You can see how there is change in the ice content in the North Pole and the Southern Pole also, and how the ozonate content is increasing and how the temperature is increasing. As a result, what you are finding that there is significant increase in precipitation in many parts of the world because of the rise in temperature and increase in humidity. And there is an increase in frequency of heavy precipitations. Entire tropical world, including India, there is increase in frequency and intensity of the heavy precipitations. And especially we are the monsoonal country, and in the monsoon season, this year perhaps you might have thought that what is happening this year. It is above normal year. We predict, IMD predicted above normal year, and accordingly, entire country is getting the frequent heavy rainfall events, and hence there is floods, landslides, mud sinks, etc., leading to loss of lives and properties. At the same time, there is increasing heat wave conditions, cold wave conditions are decreasing, hot days are increasing. So there are many such impacts in terms of the atmospheric phenomena. Now let us look at the impact on India. This is the India's map. This pink color indicates that rise in temperature. You can find that most parts of the country there is a rise in temperature, except some parts in UP and adjoining MP and Northeast India. Otherwise, the temperature is rising almost everywhere. Now, if you look at the all India average temperature, yes, it is rising, but in the recent years, in 1970 or 80s, it is quite high, and we have got 0.64 degrees Celsius for 100 years. Now, if you look at the frequency of heat wave conditions, and heat wave conditions are rising, you can see the red arrow one on the left-hand side diagram, that is the heat wave frequencies. You can see that it is rising almost everywhere, including southern India, Andhra Pradesh, Telangana, and adjoining areas also. And there are very limited areas where you will find that the temperature is falling or heat wave conditions are falling. On the other hand, you can see the cold wave conditions. You can find out that there are also red conditions. That means frequency of cold wave conditions are decreasing, and largely, and it's mainly because of the rise in temperature. Now let us look at what is happening to the monsoon, because monsoon is life for India, and it provides for bread and butter. It provides for all sources, for be it industry or be it water resources, be it groundwater, anything is dependent on monsoon, because we get 70 to 90% rainfall during monsoon season into September. Now let us look at, I have just compared here taking a different epoch. Monsoon shows the epochal behavior. Let us take one epoch for 1901 to 1930, other one is 1991 to 2020, and this is the difference of the 2 years. What you find that is blue color, or the, you can say, in the northeast India and eastern parts of country like Bihar, East UP, Jharkhand, etc. So that is indicating that rainfall is decreasing in this area. Whereas if you look at the western part, like say Gujarat, Saurashtra, Kutch, and adjoining areas, their rainfall is increasing. So while the total rainfall for the monsoon region, over the India is not showing any trend, it is trendless. The diagram on the bottom, the spatial pattern has changed. The eastern part is getting less rain, and western part is getting more rain. So, so if you look at now the monsoonal behavior, the intra-seasonal behavior, you will find that onset and withdrawal variation, there is a change. So we have got earlier map showing that 1st June is the onset of monsoon, and by July 15 it covers the monsoon entire country, but nowadays by July 8 it is covering entire country, and 1st June remains same for Kerala coast. And if you consider withdrawal, earlier monsoon was withdrawing from 1st September, now monsoon withdrawal starts from Rajasthan by 17th September. Whereas the total withdrawal remains same, that is by 12th October, it withdraws from entire country. So what you find that? The monsoonal deviation is becoming higher in northwest India, and it remains same over the South Peninsula, and it decreases in the central India. So that we have to adopt now our various measures towards agriculture, water resources, etc., so that we can adjust what is the changing behavior of the monsoon in view of the climate change. Now let us look at the length of rainy season. You will find that, as I was telling you, the length of rainy season. Okay, so you can see the length of rainy season, how, as I told you, it is increasing over northwest India and decreasing over central part of the country, and it is remaining same over the South India. Now let us look at a little more deeply what is happening actually because of this climate change. When there is a climate change, actually, say earlier, many people are now complained also, you tell us that earlier monsoon rain was continuously raining for 2 to 3 days, and it was almost uniform behavior, everywhere it was raining, but now it is not happening. If it is raining, for example, Andhra University, it may not rain in Visakhapatnam railway station. It sometimes so happens that there will be heavy rainfall in one part of the city, other part of the city may not have the heavy rain. So that type of activity has increased in recent years because of this climate change behavior. So what happens because of the rise in temperature? So there is increase in humidity and evaporation is increasing, and hence more moisture content in the clouds, and hence the taller clouds are developing and intense rain is occurring. So therefore, on the left-hand side diagram earlier, if it was raining in a larger area, now it is raining specifically in certain locations, and in addition to that, the urban heat island effect is also contributing in the urban areas. So therefore, now the distribution, temporal distribution, the distribution of time within a day or from one day to other day or within the area itself is changing, leading to more mesoscale activity of heavy rainfall events. So this mesoscale activity, that means the size is less than 10 kilometers. So when it occurring, you need such type of system where you can detect those mesoscale events of heavy rainfall or thunderstorms or lightning, etc. So this is the challenge posed by the climate change. Now water vapor feedback, it was very simple calculation I just put off that water vapor is increasing in the atmosphere, and for 1 degree rise in temperature, there is 7% increase in relative humidity in the atmosphere in the lower levels. So when there is a rise in temperature, rise in humidity, the atmosphere becomes unstable, and hence all the criteria for thunderstorm is increasing and lightning is increasing. The frequency of thunderstorm, frequency of lightning has increased over the world, and also in our country it has also increased. And monsoonal heavy rainfall has increased, leading to more floods and droughts. So another mechanism, what is happening, I just want to say that this is the case that because of the global warming, you will find that instability is increasing in atmosphere. At the same time, the temperature and humidity are also increasing. So as a result, there is increase in frequency of heavy rainfall events and increase in rainstorms over central and north India especially, even on the west coast also. Now, this is just example looking the data from 1970 or 71, because I have taken 1970 because as I told you from 1970 there is rapid rise in temperature and global warming not only in India but also the entire globe, and global warming is not limited to one country. If there is increase in carbon dioxide concentration in one part of the globe, it will have the impact on other part of the globe also. Therefore, the impact is seen from 1970 onwards. This analysis shows that there is increase in rainfall activity in all categories, like heavy rainfall activity or very heavy rainfall activity or extreme heavy rainfall activity. We define extreme heavy rainfall when it is more than 20 centimeter, very heavy rainfall it is more than 12 centimeters, and extreme heavy rainfall it is more than 7 centimeter. So what do you find that the number of events is increasing all the categories in the country. So this is the spatial distribution. You can see that the red one is the increase and the blue one is the decrease. The left hand side is the very heavy rainfall event and right hand side is the extremely heavy rainfall event. So what you find that especially central India and the northern peninsula, you have a specific marked increase in the frequency of very heavy rainfall events and extreme heavy rainfall event. And this is the region where you have the monsoonal low pressure systems affects the country. And these monsoonal low pressure systems are the major rain bearing systems, about 13 to 14 low pressure systems developed during monsoon season. Therefore, if there is an impact of climate change increasing the rainfall activity, you can imagine how it can influence the other aspects of the monsoon. So as I told you, there is no change in the monsoonal behavior. Total rainfall for the country remains same, almost 87 centimeter. But the frequency of floods and frequency of droughts, if you just look at, both are increasing. So how is it possible? It is possible because the variability, madam is here, so I should not speak, the variability is increasing. So that has become more random and variability is increasing. Therefore, interannual variability has increased, leading to more frequent floods and more frequent droughts. Now, this is the frequency of landfalling TCs. If you look at the tropical cyclones, it is a major killer earlier. As I told you, Dr. P. Koteswaram started his cyclone research in India Meteorology Department when he was posted in Calcutta. But cyclones started from 1865 onwards when the massive cyclone affected Andhra Pradesh, Andhra Pradesh causing 40,000 deaths in Machilipatnam and adjoining areas, and 80,000 people died in Kolkata because of that cyclone. It's a false point cyclone. It crossed false point near Odisha coast and moved towards Kolkata. And that led to development of India Meteorology Department in 1875. But in 1865, port warning started in Kolkata. So research started from the date of, from those days. But what I want to say that because of this climate change, number of total cyclones in the globe is not increasing. In India also it is not decreasing, rather it is decreasing. It is not increasing. But the intense cyclones, the cyclones with a wind speed of, say, for example, 150 kilometers per hour wind speed or more, that is increasing. Now, that I want to say. So, this is, you can see that landfalling cyclones also the same thing. You will see that simple TCs, tropical cyclones with a wind speed, say, for example, less than 100 kilometers per hour, it is not increasing. But if you consider the cyclones with 150 kilometers per hour, it is increasing. Especially over Arabian Sea, it is increasing. Bay of Bengal does not show any change. But there are other aspects. Tropical cyclones are moving slowly over Bay of Bengal. Therefore, even if the intensity is not increasing, while they cross the coast, if earlier they were taking 3 hours to cross the coast, now they are taking 5 to 6 hours. Therefore, the impact of landfall increases. And at the same time, socioeconomic condition of the coast has increased. Therefore, vulnerability has increased tremendously in view of this one. Now, this is the projection for the future climate change. All of us know that considering the based on SSPs, there is a projection that there will be increase. In India also there is increase in air temperatures and also there is increase in monsoonal precipitation. So, there is 6 to 10% expected increase in monsoonal precipitation in June to September because of the rise in temperature, considering RCP 4.5. If you consider RCP 8.5, it will be 8 to 14%. Now, what are the implications then? The implication of the emerging trend on the extreme weather, if I just consider, so it is required that you should go for continuous improvement in your early warning system. Because it is the first and foremost step. In South Asia, one survey was conducted that you cannot change the adaptation, you cannot change the mitigation over the night. You cannot change your preventive measures overnight. But with very small investment, you can improve your early warning system overnight. You can provide early warning in 24 hours so that people can be evacuated. If you have got evacuation centers, you can be settled there. So therefore, people say worldwide that early warning system is the major key. We should improve that, but that has to be continuous, considering this continuous impact of the climate change. So it is a value chain. It starts with observations, modeling, forecasting, and early warning. Still, the last mile connectivity. And then, of course, you have to consider the continuous improvement in impact-based forecast. Now, you cannot simply say that there will be heavy rain over Visakhapatnam. You have to say, if you are predicting heavy rainfall in Visakhapatnam, you have to say that what is the impact on transport sector, what will the impact on, say, railway station, impact on airport, Visakhapatnam steel plant, many others. So that is called as the impact forecast. We started in 2019. Now we are providing with that. For that purpose, we need the data in geospatial platform. Every socioeconomic data, geospatial data, meteorological hazards, secondary hazards, tertiary hazards, all these should be in digital form, and the decision support system should be in place for the users and the early warning service providers. Then, of course, we should have ecosystem, the elevated design standards and the natural ecosystems. We should have the integration of the climate informations with risk reduction, environmental and urban planning policies and geospatial environment. So, they are some of the important policy decisions that we have to take, and of course, country is geared towards the directions. So, improvement in institutional mechanism is also very important. There should be, just like today we are meeting all organizations from different corners of the globe, so it has to be systematically clubbed with each other. And what government says, the whole of government approach, that can help to improve the early warning system further to address the impact of the climate change. The another point is the sustainable development goal. The world gave a clarion call in 2015 that by 2030 we should have the sustainable development goal. There are different goals, 17 goals, and goal number 13, I'll just tell you, that is the climate actions. We should address the climate actions in view of the climate change so that we have got enhanced and upgraded early warning system at place every time. It can strengthen the resilience and adaptive capacity for the climate-related disasters. So this is the objective, what we should think of. And here, it is not limited only to India Meteorological Department or Indian Space Research Organizations, but it is an integrated approach for all academic institutes, R&D institutes, etc. The multi-hazard early warning system will be the key to success of disaster risk reduction, and be it during disaster, before disaster, after disasters. And for this purpose, the national policy are in place, National Disaster Management Act is in place, then we have got national plans, we have national guidelines. So what we need further is the interoperability. 5 minutes more. We should have interoperability among the various institutions, and there should be synergized standard operation procedure so that we can address towards that. So we have come up a long way with respect to multi-hazard early warning system compared to other countries. 50% of countries in the globe have the multi-hazard early warning system, other 50 countries in the globe do not have. Therefore, India is a global player. India supports other countries in developing the multi-hazard early warning systems. So for this purpose, we have got a seamless forecasting system, starting with the seasonal forecast, then the monthly forecast, then the weekly forecast, then the daily forecast, then hourly forecast. So these seamless forecast systems helps in mitigating the impact of various types of disasters. And for this purpose, we have got various types of observational network. So I will not go into details. All of us know that, starting with the satellite, we have got the radars, we have got the stations, and various networks, and all these are coming together to provide a realistic status of current atmosphere, ocean, and earth. So what we do actually, we have come also a digital technology development in the country. Earlier, India adopted the system from Meteo France. Now we have got in our own decision support system where all the components are being taken into consideration to provide on daily basis or hourly basis or weekly basis or monthly basis or seasonal basis the forecast and early warning. And this warning, as I was telling you, this is the impact-based forecast. We are giving the color-coded warning with the green, yellow, orange, red. Red means take actions. Orange means be prepared to take actions. So for this purpose, what I was highlighting that we need a data. So I request all of you, please cooperate with us, provide all types of data what we have, so that we can take into consideration the administrative layers, the meteorological data, infrastructure layers, demographic data, measure points, impact matrices, etc. can be generated based on all these data. So we are working towards all the organizations in the country, including state emergency operation centers, remote sensing agencies in our country, and also various other organizations like census, etc. So what improvement we have seen actually? There is a significant improvement, and you have seen the cyclone case, the cyclone Hudud, where we are standing now in 2014. The cyclone Hudud came here, and death was limited to only 20 to 30 or something like that. And comparatively, if you just remember 1977 cyclone or 1990 Machilipatnam cyclone or 1999 Odisha super cyclone, there is a tremendous improvement, and we have been able to now recent cyclone Dana and Viparjaya, it is 0 death. So like that, there is an improvement in seasonal forecast accuracy and external forecast accuracy and the short to medium range forecast accuracy and all types of severe weather events. Heat wave, if I just example, 2,000 people died in Andhra and Odisha in 2015. And now if you just look at the death is less than 100 in any particular year. Similarly, the heavy rainfall, if you just look at this year's heavy rainfall event, if I compare it with 2013 heavy rainfall event, which occurred over Kedarnath, 4,500 people died. And now you have death only less than 100 in individual event. So therefore, however, death should not occur, that we are trying to do that. So I am not telling in details, I will not go through. I just pass on this one. This heavy rainfall event was just imagine, so 5 years before, our forecast accuracy was 60% for 24-hour forecast ahead. Now for 5th day, 5 days before forecast what I give now, the forecast is 60%. So that means the lead period of forecast is increased from 1 day to 4 days, and at present heavy rainfall is predicted 24 hours ahead with 83% accuracy. So this is a comparison to US. People say that we are like this and it is being done better in US and other Western countries. I just compared what is the quantitative precipitation forecast by US and India. You can see that the top one is India's performance and bottom one is US performance. You can see that how the forecast accuracy is ever increasing, whereas it has been stabilized in USA. So this is the 5 years comparative forecast for cyclone forecast. Similarly, if you compare, there is a significant improvement. I will give a comparison with US and Japan. You will find that our forecast accuracy is 30% better than now US forecast. You can find people dying in US, but people are not dying in India. Now similarly, this is the dynamic impact-based forecast we are talking about. Every village level impact is calculated, loss forecast is calculated, risk finance is being done. Earlier, before cyclone, no finance was being provided by country, but at present, once cyclone is approaching particular coast, 5 days ahead, Government of India is providing finance to the state. This is called as risk financing, which is the second country after India. Now this is the death toll I was telling you, and cyclone forecast is considered as one of the most important innovation in the independent India. So this is the heat wave forecast, how you see, as I was telling you about, from 2000 we have come up to only single digit or double digit, and this is the cold wave forecast. And this is the nowcast for thunderstorms. So this is a very important thing I will tell you. Thunderstorm is such a phenomenon, which occurs very small area, and also time of the occurrence is very less. Its prediction is a real problem. So what is happening actually at present, we are providing thunderstorm accuracy through common alert protocol in local language, say in Andhra Pradesh Telugu language, it is going to each and every person who have the phone. He will get the information about the occurrence of thunderstorms or rainfall, etc. Now this is the thunderstorm forecast accuracy. There is a significant improvement in recent years, but internationally, therefore, we have got a recognition, and we are providing support to all South Asian countries, Southeast Asian countries, and Middle East towards this. But if you look at the future, still there are gap areas. The most important gap areas with respect to thunderstorms, hailstorms, squalls, lightning, etc. So there is a huge gap. We have to improve it further because the lack of gap areas is mainly because of the observational systems, then modeling and forecasting systems. We are working towards that directions. But as it was being told that AI is playing a different role. We have started using AI models, but we do not have AI models at present. European model is being utilized, for example, cyclogenesis forecast for the day-to-day forecast, etc. It is a part of. You cannot utilize AI completely. We have to utilize both physical models and AI models. So what we see that there is a digital twins or the dual engine concept where the physical models and the AI models work together, and we will have this conversion of data to value with the help of the AI. So what is the need actually? We need actually crowdsourcing and citizen science. We have to go for citizen science. Every individual by 2047 will be a scientist, I will tell you. And they will provide information what is happening, and they can also help in improving the forecast and early warning of the system. Then artificial intelligence, machine learning will be the key. Digital forecasting will be in place at that time. There will be no human role. We can just interpret and help the people. And impact-based forecast will be there for each and every severe weather. So there will be last mile connectivity. At present also we have the limitation towards last mile connectivity. Say for example, people in the sea, the system NAVIC has come up with the ISRO and Minister of Earth Sciences working together, but still we have got the gap areas and Himalayan areas, other places also. Then low cost technology, as you are telling that Viksit Bharat, independent Bharat technologically. So there is a huge gap here in the field of meteorology. You will see that we do not have sufficient technology which is indigenous in nature. A simple sensor for automated weather stations are being imported. The software for radar, we are giants in software, but software radar is also being imported. So there is a huge scope here for the research community here, students present here, to work towards the development of indigenous technology. Now the future plan, there are various plans of 2047, but I will not talk about 2047, but I say that by 2047, I will tell you there will be no severe weather which will not be predicted or detected, say up to 7 days or 15 days. And each individual will be a citizen scientist, and it will be a massive force in the country, not only to provide, it will be a global leader to provide support to all the countries. But what I want to say that in the next 5 years, by 2030, the forecast accuracy will improve by 10 to 15%. And for this purpose, mission Mosam has been taken off. It is under Prime Minister's idea. It has been taken off, and under which we have a massive plan for observational network. Why observational network? Because weather forecasting is an initial value problem. If you can have the initial status of Earth, ocean, atmosphere correctly, then you can predict it correctly. So therefore, everywhere in the world, that is the initiative to improve the observational system fast. Then of course, you will have computation, the quantum computing, other things are coming up, modeling, physical modeling along with AI model will be there. But the key is the observational systems, and the mission Mosam will be the first platform to improve the observational systems, through which we will have 126 radars. Apart from other observational systems, what I mentioned here, objective is that entire country should be covered by radar. There should be redundancy in terms of radar. And also, for urban areas, there will be multiplicity of radars. For hilly areas, there should be multiplicity of radars. For coastal areas, there should be multiplicity of radars. So that there is 100% nowcasting, that is 3 to 6 hour forecast. And also, there is lead for increase of 7 days with the augmentation of data and the data assimilation in the numerical models. So there is a future, good future with the implementation of this mission Mosam within the next 2 years. By 2027, it will be implemented, and its repercussions can be seen. Good repercussions, of course, we can see by 2030. I am sure there will be forecast improvement by 10 to 15%. So thank you very much for giving this opportunity to speak on this occasion.
Thank you, Professor Mohopatraya, for an excellent talk on the climate change. Climate change is an important aspect. All the developed nations, developing nations, and underdeveloped nations have a different viewpoint on climate change. Hopefully, we'll all work together to solve these problems. Before I call upon the next speaker, I just like to say a couple of words on the ASTC. ASTC is the organization that is now organizing this program along with the Andhra University is Academy for Science, Technology and Communication. It's a brainchild of Mr. Narasimha Rao, who is sitting in the audience. Nearly about 2 decades ago, he started this organization, and since then, we have been conducting large number of programs across both the Telugu states to promote science, and most importantly, to take the science to the common man, so that benefit of science is transferred to the people who need it. We have been quite successful in doing so, and I hope that we will be able to do in future as well many such activities. This is time for me to invite distinguished lecture to be given by Dr. Prakash Chauhan, Director of NRSC, Hyderabad. He is going to speak to us on Indian Space Program for Societal Benefits, a game change for Viksit Bharat. Dr. Chauhan, please.
Good afternoon to you all. First and foremost, let me thank Andhra University and the Honorable Vice Chancellor, Professor G.P. Rajshekharji, for inviting me here on this very auspicious occasion of Teachers' Day. It is always good to be in a university setup amongst various gurus, those who are sitting here on dais, and many gurus which are sitting off the dais, and of course among the dear students. So on this occasion, I would also like to pay my rich tributes to Bharat Ratna Dr. Sarvapalli Radhakrishnan-ji, a great teacher in whose memory, we are celebrating Teachers' Day every year. And at this moment, I would like to recall the great Hindi, in Hindi we call dohas. So there is a mystic poet called Kabir, and Kabir has, very beautifully described the importance of teachers in 2 lines. And the doha is, Guru Govind dou khade, kake lago paye, balihari Guru aapne, Govind diyo bataye. It means, teacher and the God, both are standing in front of me, to whom I should go first and touch the feet. So, I will do it for the teacher because it is the teacher who has taught me about the God. So, the teacher comes much before than the God as per our Indian traditions. So, my salutes to all my teachers as well as all teachers in this auditorium on this very auspicious day which we celebrate as Teachers' Day across the whole country. Now, coming back to this event, today we heard an excellent lecture, and of course, the introductory talks by various luminaries, and a wonderful talk which has set and which has made my talk, much easier now by Professor Mahapatra ji, our Honorable Director General of IMD. He has in detail described you the entire process of climate change as well as what has been happening since the early industrial era and what kind of observational networks we are having today in terms of understanding the climate variability and weather forecasting and what is required to be done. In that context, space also plays a very important role. And because we are running short of time, I would like to, take some less time, but in that less time, I will tell you that how is the space technology changing our lives here on Earth. Friends, when it comes to space, many of you only imagine about galaxies, you imagine about stars, you imagine about our own solar system, you think about planetary bodies within our solar system. And many people, especially young students, think that when it comes to space, we only worry about, the extraterrestrial space much beyond our own planet Earth. But that's not true. Even though the space technology is being used to explore our own solar system, our own galaxy, as well as the entire universe by putting large amount of telescopes, by putting satellite systems to know about our own neighborhood and vast universe. But it's also true that space systems are also being used to know more and to explore more about our own home planet, that's the planet Earth. And that story I will tell you. I will not take you to moon, Mars, and not to sun and not beyond sun. I will keep you here on Earth and tell you that how space technology is changing our lives when it comes to the space-based systems. So that's why the title of the talk is Space Technology for Societal Benefits and how it is going to play a very important role in realizing the goal of Viksit Bharat. Now, when I say the space we are moving towards space ubiquity. That means space technology is there everywhere today. So we have these three sisters, I call them, in space. One is satellite communication, another is satellite navigation, and third is Earth observation technology. So these three, satellite systems are essentially changing the life here on Earth. If we stop satellite communication from our all satellites, either launched by ISRO or by any other space agency or any other private company, even for 5 minutes, you know what is going to happen? All of you are not going to get television network. All of you are not going to get news feedbacks. Many of you will not be able to transact from your ATMs. Money withdrawal will stop. So shut down all systems. You will come to know what happens. Even the pizza which comes to your home or a delivery boy is not going to reach to your home if the satellites are not providing you, the navigation satellites are not providing you the positions. Your continuous location is being tried, by a suite of satellites called GNSS technology, Global Network Satellite Systems. And one of them is typically called the GPS system, but India has also have our own regional navigation system called GNSS or NAVIC system. The third one is Earth observation technology. Dr. Mahapatra talked about weather system observations. Atmosphere, such a rapidly evolving, system. Every minute, the atmosphere changes. So to measure this atmospheric variability in space and time, we have put meteorological satellites at 36,000 kilometers away. It's called geostationary orbits. And today, India has two such satellite systems in geostationary orbits, which provides you every 15 minutes weather updates and weather images and at least 26 geophysical parameters about the weather systems of around India. And these data sets get assimilated into the weather forecast models for precise forecasting apart from the ground-based network data sets. So that's the importance of the Earth observation technology. India is a country which is growing with a 7 to 8% growth, and our urban landscapes are transforming like anything. Every 6 months in your Vizag itself, there will be a new building, and if you buy a flat in that building, and if you want a grocery service, but if that building is not there on the map, what will happen? You will not get all those services. So the high resolution satellite technology is being used to provide and update the digital mapping services. So every 6 months, some company can create a new digital map, put your building onto that map, and then you get your location-based services in terms of logistics and all. So this is the power of space technology, and that's what we call the space ubiquity, that in all spheres of life, the space technology, whether you know or you don't know, it is playing a very important role in shaping, the lives of the common people, as well as it is also helping in terms of achieving what Dr. Mahapatra talked about, the sustainable development goals, which basically have been prescribed and prescribed by United Nations, so that we have a society which is developing in a sustainable manner. Now, today, when we talk of space, the space activity, as you all know, started somewhere, with the launch of first satellite by USSR. We used to call it Space 1.0, where, initial space exploration was done by the supreme powers of the world. Only Americans and Russians, or those days Soviets, were involved in the space exploration. But then the new players joined. Subsequently, India also started space program with the vision of Dr. Vikram Sarabhai in late 60s. And that's how, more space-faring countries started evolving. That's we call Space 2.0. Space 3.0, when people started sending, the operational satellite systems for providing services. But mostly these services was funded, and the satellite systems were funded by the government money or the public money. But today, that's not the scenario. The space has opened up even for the private sector participation, and we call it the Space 4.0, where space has become a commercial enterprise. Today, there is a thriving economy. I will not talk about numbers. You can read it there. Globally, there is a huge space activity taking place only for Earth observation, satellite communication, satellite navigation. But our contribution, India's contribution, is only 2% or so. And government want that in next 10 to 15 years, this should increase up to 10%. And for that, we have done the policy interventions. New space policy has come up, which is allowing participation of private sector in all domains of space technology, either it is building satellites, launching satellites, running ground stations, or also providing satellite-based services. So that's the era in which today we are there, and that has led to large amount of newer players entering into the space domain, including the startup companies. Let me tell you, especially for the youngsters, in last 3 years itself, more than 300 startup companies have registered in India, only exclusively in different aspects of space domain. So that's what we call as the space economy. And that is going to provide very critical job avenues for our young people, those who are, talking of deep tech space startups, which is basically is going to be the future. So in that context, the space economy becomes very important, but all of that is happening all around what we call as the Indian Space Research Organization, or ISRO, which was set up in 1969. This is the history. Today, we had 102 launches of various kind of rockets, which takes this different type of satellites into the orbit. And then, of course, large amount of work is also happening on a human space program. India has a very dedicated Gaganyaan program where 3 Indians are likely to go into space. Recently, you must have seen, our Shukla ji, the second astronaut who went on who became the first astronaut to go into International Space Station and come back. But that's going to unfold when we will send our own astronaut by our own Indian rocket, and it's likely to happen in next 2 years or so, because this Gaganyaan program is in an advanced stage. And of course, we also send large number of satellites for foreign players today. India is the fifth largest spacefaring nation in the world today. That is starting from virtually nowhere. So this is the story which we are talking today of indigenization, but in ISRO, we have started indigenization almost 50 years back or so. So when it comes to the current infrastructure in space, we have around 58 satellites, which is not adequate. If you look China, if you look USA, our number is almost 1/10 of that. We have satellites for Earth observation, communication, navigation, and of course for space exploration. But if you talk of the kind of applications which are basically driven by these type of satellite systems, virtually no field: agriculture, climate change, disaster management, mineral exploration, energy sector, transportation sector, marine economy, fisheries, all kind of sectors today space data is being used, and I will show some examples to you. Now, when it comes to only Earth observation satellites, we are having 4 series of Earth observation satellites. We have satellites which basically are useful for the natural resource assessment. They are the satellites which provide information on forest, water services, minerals, geology, land use, soils. There are satellites which provide you very high resolution data of the order of 20 centimeters or so, which are used for urban planning, which are also used for security and defense of our own country in terms of adverse situations, especially during Operation Sindoor. These satellites have provided very important information about the impact of our activities which we did in the neighboring countries. And of course, the oceans. Ocean covers 70% of the globe, so oceans are very important. So we keep eye on oceans also. I'll show some examples. And of course, weather and climate. Dr. Mahapatra already talked. We have this INSET 3D. 3DR and 3DS, 2 satellites which are operational, which every 15 minutes provide you large amount of meteorological data sets. One more important thing which I would like to just tell all audience here, in the month of July, on 30th July, we launched this very ambitious NASA ISRO synthetic aperture radar mission. This is the very expensive mission. It's a dual frequency synthetic aperture radar. The radars have a capability to see through clouds. It also has a capability of day and night imaging. So India has developed this S-band frequency radar, and the L-band, which is a longer wavelength, has been developed by NASA JPL, and this has a 12-meter reflector antenna. You can see that big reflector. This gives you an ability to see larger area on Earth, what we call as swath. So with 250-kilometer width, basically at 6-meter resolution, we will be able to see the Earth on an unprecedented scale, and large amount of scientific work in terms of understanding of our cryospheric systems, in terms of understanding the changes in the polar systems, in terms of understanding the ecosystem changes in our forest, and of course, the changes which are caused by the solid earth processes like landslides, earthquake, they all going to get monitored with the help of this NISR data. And I am very happy to inform that all this data is going to be available to Earth Science community free of cost through National Remote Sensing Center from November onwards. And many of you, those who are interested to use this type of radar data, I am sure that many of you may contact us, and then we will tell you that how you can utilize these data sets. Another aspect, of course, when we are talking about data, today we are an economy which is data hungry economy, and for each decision making we need data. Even your AI models need data. Without data, AI is of no use, and data should be authentic data. So space systems provides you repetitive, large scale, big volume data by these satellites, and all the satellite data is today has been made available free of cost by the Indian Space Policy 2023. So NRSC is now providing 5-meter spatial resolution multispectral data from all ISRO satellites free of cost from this Bhunidhi portal. And some of you, those who are interested in utilizing this satellite data, can visit our portal and we will be able to help you out. Now, when the satellites go into space, they normally operate around 300 to 800 kilometer altitude, and they do different kind of functions. But some of these high resolution satellites provides you unprecedented detail of the Earth. Now you can see this is the image of one of our satellite called Cartosat-3 satellite. It has a capability to see 20 centimeter by 20 centimeter object onto the Earth. And you can see the old, the Parliament building, new Parliament building, entire Rajpath, and even the cars are seen. This is another detailed image over a power plant, which you can see the kind of details which are available from space today. So this kind of imagery becomes very critical for the national defense and security purposes also, and we can do monitoring all across the borders and monitor the activities of adversaries. But the limitation with this optical imaging is that you cannot see through clouds. You cannot see in night. So we have, what we call as the active radar sensors or the active remote sensing satellites called radars. And we have also developed indigenous capability in the country to send these synthetic aperture radars into space. And this is how some of those imageries looks like from synthetic aperture radars. So these are not only two-dimensional pictures of the Earth. We can also get the third dimension from space. And by using a technique called photogrammetry, when we can put two cameras which are separated by a distance, we can generate the third dimension and generate the entire topography. So we have mapped the entire country using a satellite called Cartosat-1 at 2.5 meter by 2.5 meter grid interval, and you can create digital twins of any topographic variations using this satellite data. And I will show you one example. Sitting here in Visakhapatnam, I will take you to Himalayas, and I will show you that the place from where the Ganga originates. Now we are traveling, we are flying over to Gangotri Glacier, and this is Bhagirathi River here, and you can see the mountain setting by utilizing this three-dimensional data and overlaying the satellite imagery. Now, this is the Gangotri Glacier. This is how a glacier looks like. Some of you sitting in Vizag must have not seen glaciers, but look, you can see and feel that as if you are flying over this terrain. That's the power of geospatial data today. These are the crevasses. Many of these glacial systems are cracking because of the warming in the Himalayan region, and this is the upper reaches of this glacial system where fresh snow also you can see. So these are not beautiful animations and movies which you can create. This is data. You can calculate slopes of this mountain. You can calculate this, the slope of the glacial system, and this data is repetitive in nature. Every 15 days you get this data. So any kind of changes which are happening on glaciers, which are happening on glacial lakes, they all can be monitored using these satellite data sets. You can train your artificial AI models based on this kind of data, detect changes rapidly, and take decisions out of this data. That's the power of the satellite data, which comes as far as the decision making on Earth is concerned. So as I told you, these are not only photographs. These photographs, when converted into a valuable map service, starts providing you vital data on social and economic security. It gives you information about agriculture productivity. You can differentiate different crops. You can find water in different reservoirs, the water level variations, can be mapped on a regular basis. You can also use this data for finding energy security. Using crop assessment, you can find out how much crop residue is going to be there, and you can think of converting this crop residue to bioenergy potential. So energy security also becomes important. You can do planning. If you want to plan a new city in Andhra Pradesh, you can use this satellite data and see that what kind of topography is there, what kind of natural resources are available, and accordingly you can start doing urban planning. And of course, disaster management. You can use this satellite data in all spheres of disaster management. Essentially becomes very important. Post-disaster for damage assessment. I will show a couple of examples. In case of agriculture, there are certain case studies. At national scale today, we are using satellite data for assessing almost 13 crops, their area, productivity, and of course settling the claims of the farmers in case of crop insurance, in case of crop losses for insurance purposes. These are all now operationally being done by Ministry of Agriculture and Environment and Forest. You can do parcel level, farm by farm mapping of agriculture productivity using these satellite data, essentially providing very valuable tool for what we call the digital agriculture information system in the country today. Similarly, this is one important data which you can see Dr. Chaudhary will talk about in the afternoon. The crop map, rice map. All of us are eating rice, but from where this rice is coming? India is the second largest producer of crop grain today. I am showing you a map produced by a synthetic aperture radar for the rice productivity. All that yellow things what you see is the most product from where the rice comes to your table. And this has been done by processing millions of satellite images in a completely automated manner. We can discriminate the rice crop and then generate national level rice crop map just before the harvest itself. And it becomes very useful for decision making for import, export, and of course price and market intelligence as far as the rice production. And similarly 11 such crops are being mapped today for productivity. Water also is very important. We are now providing large amount of data for water resources to the country. We are giving a service called Water Map service. So all major reservoirs of India, you can map every 15 days and get the water level status from a project which we did for the Ministry of Jal Shakti called National Hydrology Program. This is one example of that how the reservoirs are shrinking or how they are expanding because of the rainfall activity throughout the year. Another important aspect to keep eye on Himalayas. Himalaya, as Dr. Mahapatra was telling, a very large remote area, more than 2,000 kilometers length and more than 300 kilometers in width, all across Hindu Kush to eastern Himalayas. We are able to produce 15-day snow cover maps, and these snow cover maps are converted into snow water runoff melt. So whatever hydropower is being produced by hydropower producer, they want to know that how much snow will melt and how much water I am likely to get so that I can produce electricity. This type of snow melt forecast is very important for them, where space becomes a very vital input. We talked of climate change. Climate change has a large impact in the Himalayan region because the warming rates are much higher compared to the plain areas, and many of these glacial systems are rapidly melting, and there are glacial lakes, and many of these glacial lakes are expanding. This is one example of a glacial lake. In 30 years, this lake has expanded 3 times. Many times this glacial lake burst also. You have seen the case of Sikkim. These events are called GLOF events, and they need rapid monitoring or enhanced monitoring. So satellite becomes very useful tool. There are more than 26,000 such lakes all across Himalaya in 3 river basins. This is the example of that South Lonak Lake, where we could, of course, it's a post facto analysis, but we could show that what caused this, GLOF based on these satellite observations. Energy is another very important dimension. If we have to fulfill the goals of, achieving net zero emissions by 2070, we have to do transition from hydrocarbon-based, energy sources to clean and green energy. Solar irradiance mapping using our meteorological satellites becomes very useful when it comes to the availability of solar irradiance for putting solar power plants. And of course, the bioenergy aspects also can be mapped very nicely. This is one example where we have used AI because we can pick up the solar panels from space, and by training an AI model, we could estimate that more than 10 hectares and bigger solar farms what is their location, where they are in the country. And you can see Telangana and Andhra, Telangana and Karnataka has large number of solar installations when compared to any other country. By the way, now India is generating around 200 gigawatts of energy only by solar. So that's the kind of transition in terms of energy space is happening, and we can monitor and calculate the carbon emission reduction by providing this type of databases. Disaster also a very important aspect. Forest fire, flood mapping, landslides, all these areas basically we can provide inputs from space. I will not go into details of it. We can discuss offline. This is one example of the event which has happened in Dharali in Uttarakhand recently. These are the two images before the disaster and after the disaster, and you yourself can see the level of devastations which has happened. We have estimated the amount of damage. All these red regions, what you are seeing is the number of buildings which got collapsed. And then this data becomes very useful for what we call as the post-disaster need assessment, because the state governments want funding from the central government for reconstruction and rehabilitation. There has to be a baseline data, and all that baseline data comes from the space technology-based observation, because there is no other way. He has talked about meteorology and weather forecasting in detail. I will not tell much into details, but these satellites are also backbone of all meteorological forecast system. We have this wonderful spacecraft called OceanSat-3, which has a beautiful instrument called scatterometer. It provides you very high resolution wind vector over oceans, and this data becomes a very important data source, not only within India, globally, in which goes and gets assimilated into weather forecast models. Of course, oceans, as I were talking, 70% of the earth is ocean, and ocean provides large number of resources. On our OceanSat-3 satellite, we are mapping the phytoplankton distribution in the ocean and also calculating the total productivity of the ocean. This is an example of global imagery of phytoplankton variability. So not only the carbon is being fixed on the land, carbon is also being fixed in the ocean. All these green and red regions you can see, they are the most highly productive areas on the globe, and the blue regions and cyan regions are the deserts in the ocean. So there are not only deserts on the land, there are deserts in the ocean where productivity is not much. And if you are looking for fish hunting, you have to go to some areas where productivity is more. And based on these principles, today a national service called Potential Fishing Zone Service is operated by Inquise, where more than 9 lakh fishermen are basically getting benefited in terms of knowing in advance that which are the most potential areas where they can go and do profitable fishing. All these things are not only just information, but they are now services, and many of these services are being rendered by various geoportals which are developed by ISRO or by sister departments where the space data is getting incubated. Some of these portals like Bhuvan, Mosdaq, or many other portals which are also done through IMD on weather data, you can access on internet services. Very briefly, I will just touch upon our GNSS constellation, Navik. It's a regional constellation, but it's very critical for our data, sovereignty, our independence in terms of providing position services from GPS. And that's how it started in 1999 when Kargil war happened. Today we have certain difficulties, but very soon we are going to augment the Navik constellation. There are 4 satellites now, but within 6 months there will be 6 such satellites which are totally, providing much better high precision location based services compared to the GPS thing, and all our defense equipments are now getting enabled through NAVIX, so that we have the total GNSS sovereignty when it comes to defense operations and a lot of civilian applications using our own inbuilt India made NAVIC system. It has large amount of applications. I need not talk, many of you are aware. But this is another core area where large amount of space economics is likely to grow, and many services like fishermen services, disaster services in high seas, in remote areas are now being operated through this GNSS constellation. In case of Earth observation also, recently we conducted a national meet in Delhi to know the demands of the country, and I can tell you the country is really data hungry. We are not able to fulfill their demands because of certain policies which has been introduced recently. We are now doing users stake consultation, including Met Department and Ministry of Earth Sciences, in terms of bringing out futuristic satellite systems. So some satellite systems are already approved, and we anticipate that in next 10 years, there will be around 200 satellites funded either by the government or by the private sector or in a public-private partnership mode, so that the space economy is really going to get triggered. And this will provide large amount of opportunities to our young population. As I told you, the space is not only limited to government laboratories today. There, if you come to places like Hyderabad, Bangalore, or Pune, more than 300 startup companies are actively working and challenging even established department like Department of Space in terms of innovations. So with these, new policy dimensions which are coming up, I am going to see, and I am seeing that the space is going to be a game changer when it comes to providing, the governance, service delivery, as well as, the information to our citizens. I did not talk about the Starlink and the satellite-based internet services, but that's also going to be on horizon. SpaceX is already providing it, and there are many companies in India which are likely, they are making plans to launch satellite-based internet services like a DTH antenna. You will start getting high-throughput internet at your home itself. So that's another dimension which is likely to come up very soon. This entire sector is going to be so transformative that 5 years down the line, you will see that the amount of penetration of space technology, let's say if it is 80% today, it's likely to become 95% in 5 to 10 years. With these words, I would like to thank each one of you for your patience hearing, and thanks to organizers for giving me this opportunity. Thank you.
Thank you, Dr. Prakash Chauhan. Some time ago, we had a meeting where Dr. Prakash Chauhan was there and another Prakash was there. So all the Prakashes were together prakashing on the planet Earth. And we had a very nice talks, two talks on space and as well as on the planet Earth. And if we spoil planet Earth and it becomes not livable, let us go to space and somebody will take us there. Yeah. Before I invite other speaker, I see this NCC3 both side students standing all the time. I don't think we have any security risk here. You can change the space, or you can please sit down. Don't bother to really stand so long. Okay. Now this is my pleasure to really invite our chief guest, Padma Shri Professor Sanghamitra Bandyopadhyay. Mr. Narasimha already introduced Sanghamitra Bandyopadhyay. As mentioned by him, she is an eminent scientist and known in the area of artificial intelligence and statistics. And she is a fellow of all the academies of sciences and also the World Academy of Sciences and Bhatnagar Award winner. Many of us on the dais are Bhatnagar Award winners and as well as the Academy Fellows. But she is also Infosys Award winner in addition to all these things. It's a pleasure to invite her to give inaugural chief guest message.
So will I be visible? Oops, there's a lot of water here. There's a lot of water. Yeah, okay. It's okay. We'll just a very good afternoon to all of you, and happy Teachers' Day. The Vice Chancellor of Andhra University, Professor G.P. Rajashekhar, Director General, Indian Meteorological Department, Dr. Mrityunjay Mahapatra, Director, National Remote Sensing Center, Hyderabad, Dr. Prakash Chauhan, all other dignitaries on the dais and off the dais, the staff members, the faculty, the students of Andhra University and guests, ladies and gentlemen, it's a pleasure to be here on this occasion of Teachers' Day when Andhra University is celebrating its science, the Teachers' Day through a science conclave on science and technology frontiers for Swarnandhra and Viksit Bharat 2047. I also take this opportunity to thank the Vice Chancellor, Professor G.P. Rajashekhar, who has been a long-term friend. I mean, I was just talking to him yesterday night. I looked up my email. When was the first email that I received from G.P. Rajashekhar? That was quite some time back. And he reminded me, even prior to that, we've been in touch through various, evaluations of students, etc. So I think from last 20 years, G.P. Rajashekhar has been a friend, and of late, we also served on some committees together. So thank you very much, Professor Rajashekhar, for inviting me here, giving me this opportunity to interact with the Andhra University family, and also getting to know so many distinguished colleagues, distinguished people. G. Narahari Shastri, I've been friends with him for a long time now. So it's a pleasure to be here, and especially on this day and on this campus. Teachers' Day, and on the campus of Andhra University, where Sarvapalli Radhakrishnan, he was the second Vice Chancellor. This is hallowed land. It is a privilege to be here on this day. The second Vice President of the country, and then the President also. Sarvapalli Radhakrishnan was before, he was much later, he turned to politics. But he was, and to us, he remains the greatest teacher, an educator, a philosopher, a statesman. Very late, I think, he went into politics. And that is how I think it should be if all of us are to really build this country, Viksit Bharat 2047. Education has to be the fundamental, the pillar. Now, I see from the schedule of today's meeting, today's event, we are quite heavily delayed. So a lot of time has been allotted to me. I thought that anyway, I was bothered actually earlier when I noted 40 minutes devoted to my talk. I was bothered because these days, you see, holding on patience and holding that attention, it's impossible. 40 minutes, impossible. We are used to this 1 minute or 30 seconds videos, right? YouTube videos, we just scroll up. So sitting and listening to somebody just saying something for 40 minutes, impossible. But I think all the elements got together, and it so happened that I will not be speaking for 40 minutes anyway. I'm not going to bore you for 40 minutes. I'll try to keep it as short as possible. And also, as I said, Andhra University, it's with its rich legacy, this university has really produced stalwarts, and that is where Andhra University now, in the Swarnandhra dream, it has to play its role. It is already playing its role, and we must all get together, whether we are from Andhra or not. And not only, for this state, if we have to achieve that vision of Viksit Bharat 2047, of India becoming a developed country by 2047, all the states, all the states are the pillars of the nation. So all the states have to become golden, have to be empowered, and along with that, the Swarnandhra, of course, it has to become Swarnandhra, so that the Viksit Bharat dream is achieved. For too long now, we have been a developing country. I think we have run out of patience of being a developed country, and the entire country is now enthused, is looking forward to. We have that confidence now that yes, we will become a developed country. For too long, it's a developing country, enough of it. So, and that will not come just by saying. We have to actually get together. All institutions, all states, we need to help each other out, to empower each other so that final vision is achieved. We are in the education domain. So education, from the education point of view anyway, with this AI, machine learning, everything coming in such a big way, education, I think educationists are confused of what to teach, how to teach. Students are not coming to classes these days. Their attention span is so low. So what to do? What are the innovations? Are we innovating enough in the education sector to hold on to those students, to produce those fantastic scientists for tomorrow? the fantastic administrators for tomorrow, with integrity, with value system. That is something which is imperative, because a society which is built on integrity and the value system, it's only that society which will be truly developed. So are we doing that? Not yet, probably. We are on the way, not yet. So we have to get together, as I said. And here I will give one model that we have in the institute that I come from, the Indian Statistical Institute. We have a program which is at the master's level, at the MTech level. It's called PG, Postgraduate Diploma in Business Analytics. And that is run by IIT Kharagpur, IIM Calcutta, and ISI, the three institutes together. First semester, the students are in ISI. Second semester, they move to IIT Kharagpur. Third semester, they are in IIM Calcutta. And the fourth semester is a dissertation in some industry or somewhere. So, and the certificate that the student is getting is signed by all the three institutes together in the same certificate. So it's a great learning experience that the student is getting from three top institutions of this country. This model has to be repeated. It is there. We are now floating some more and more joint programs, but that is where, if we do not have all the expertise in one place, we have to join our hands together. The education is, and it is not easy, because three or multiple institutes, they have their different rules, they have their different ways of operations, they have their different statutory bodies to take clearances from, different principles, etc. So it's not easy to get people together and come to a common platform. It's very challenging. But then it has to be done if we are to give the students their best learning experience. Another model that we have now, the second year we are running, we have started a Bachelor of Statistical Data Science program in ISI. ISI is not in a single location. Our headquarters are in Kolkata, but we have two very strong centers in Delhi and Bangalore. And our resources, including the teaching resources, are spread across many different centers, including these three, of course. So we were not able to float a bachelor's program, a new bachelor's program in a single location, because not enough faculty was there. Now what we did was, we made it a classroom program, because classroom programs have its rigor. We wanted to keep that rigor of the program, so it was a classroom program. 25 students sitting in Delhi, 25 students in the classroom in ISI Kolkata, 25 students in ISI Bangalore Center. So 75 students in all, teacher in any one of these locations, either in Kolkata or in Delhi or in Bangalore, and teaching assistants in wherever the teacher is not there, at least to monitor the class, the teaching assistant will be there, and use of technology. It's the students in other locations are getting the teacher live, but virtually. They can ask questions, interact, all these things. We are trying to replicate a classroom environment, but digitally, as one of the speakers before me said. So we have to use such technology, and it need not be within a single institute. This is the model where I think we must collaborate with other organizations. Wherever there is a strength and we are lacking that strength, we have to get together. And that is how I think we can actually take the country ahead, take the country forward. In today's era, where artificial intelligence, machine learning, data science, it's everywhere. AI is everywhere. Anything you do, there is a component of AI which is built in there. I have been doing artificial intelligence for quite some time now. From my research days in the 1990s as a faculty, and even today I keep on doing, from a computer science perspective, developing algorithms which fall in the broad category of artificial intelligence. So earlier it was much simpler, right? We were doing, let's say, even the remote sensing images. I have done several series of works where we had taken spot images, the French satellite image, as well as IRS images, and we were doing land cover classification. So where is water, where is concrete, where is a bridge? In fact, I remember we had an image of Calcutta, of the city of Calcutta, and you would know that there is a river in that city and a bridge going across this, the Howrah Bridge going across it. And at the time the image was taken, a new bridge was just getting built. So there were two small protrusions from two ends at a certain part of the bridge. And whichever algorithm was able, because that bridge was a small, thin concrete structure over a body of water. So whichever algorithm was able to detect that bridge very nicely, we wrote papers on that. Okay, I'm able to detect so much of this bridge. I'm able to detect so much of that bridge. That was the work we were doing way back, 20 years, 25 years back. Now from there, AI has evolved, has changed so much that it is now, earlier what? Earlier the AI was under the control of human beings, under the control of the programmer, of the researcher. Now AI is challenging the human being. AI systems have become so complicated, they can learn. You simply throw data at it. If you throw enough data and if you have enough computational power, it will learn. You don't need to tell it what to learn. Earlier, whenever we had a problem, we had to extract some features, and these features we had to input to the AI system for it to learn. That was machine learning, right? There's a difference between artificial intelligence. Machine learning is a part of artificial intelligence, but not all AI is machine learning, but all machine learning is AI. Machine learning, when we are learning something from the data. Now this machine learning has transitioned into deep learning, because now we have huge number of layers of a neural network, and that is why the word deep has come in. It's essentially neural networks which are there in various deep learning systems. So we are throwing data at it, we don't know what it is learning, but it is learning something, and the results are much, much better than what it used to be. But what is it learning? We don't know. And remember now, what has become extremely important is the quality of the data. If you give it bad data, whatever it will learn will be very biased. That is why we have so much of bias also in AI-based, machine learning-based systems. For example, there was this case where it was found that in the US, a lot of data in the medical domain was put into the system, but the majority of the data points were on the white males. So it was doing very badly. It was predicting for colored people something which was very wrong, that was bad for their health, because the data itself was so biased. It is now becoming so and more important to recognize the bias in the data and to handle it, to tackle it, so that the data will be a true reflection of the society. There are many, many AI systems which are so heavily biased against women because the data is men heavy. There were many, in fact, at one point of time, even all the medicines which were getting tried through clinical trials, the main subjects were Caucasian males, where it would really harm the health of women or other communities. So in India, for example, the vaccine which we had developed, it is in Indian conditions for India. So we have to solve our own problems. It's not the solutions that we take from elsewhere and then apply it here. It will not work as well as it should. We have to develop our own knowledge, our own technology, and that is where all institutions like ours, the IITs, the Indian Institute of Science, Statistical Institute like mine, the Andhra University, everywhere we have to play our roles. And university, if you see worldwide, it's the universities where, in the top countries of the world, it's the universities where the true innovation happened. Somehow we have to bring that interdisciplinarity back in our systems, and we are doing it. All the institutions now, the NEP 2020 has focused so heavily on such a university-based system, need not be necessarily a university, but a system where multiple disciplines thrive. It is only there that innovation and excellent knowledge generation can happen, because people of different mindsets, different expertise, they get that platform of interacting, talking together. You really don't have to always work together. Taking tea together is enough, because you are talking to each other. That is so important, and that is where I think we are headed now. But AI, it is now actually impinging on what was human expertise, and it is scary. It is actually scary, because now AI is generating music, AI is generating poetry, AI is, generating videos. This generative AI, where the AI is generating new content, that is where I think we are really facing. We have to be very, very careful, especially in a country like ours, where through AI, we can see things which have never happened. It's just generated. We can hear words which were never spoken, just generated, and that has the potential of causing havoc. In such a country where we have so much of diversity, so much of different opinions, etc., anything that can instigate a section of the population, that can create great disastrous situations. So we have to be very careful about how we use AI, about the controls on the artificial intelligence, the regulations there, the accountability, transparency. There's no explainability, right? I mean, AI system will tell you, okay, this is this, and this is this class, and that or that class. But why? Because there's now, as you know, all of you know, that AI is heavily into healthcare. But then explainability has to be there, otherwise the physicians, the doctors there will be less adoption of AI because unless it is able to explain its decisions. A lot of work, of course, around the world is going on. I am myself working on explainable AI. I have a PhD student who's been working on this, how to lend explainability to the AI models so that it can tell why it has given a certain decision. There are a lot of students here, so I would just like to encourage all of you, all the students, as has been mentioned multiple times on this very dais, please also keep entrepreneurship in your career as one of the career prospects. Entrepreneurship, because this country, the government or the jobs that others have generated, it's not enough to feed so many people. It's not enough to give work to so many people. More and more, our students go into this startup culture, into this entrepreneurship domain. More and more, not only will knowledge get generated here, we have to have knowledge generation in the country, ownership in the country, the intellectual property owned by us. We have to create the Googles and Microsofts in India, not somewhere else. The more and more that happens, not only will it be a translation of the work that you've done, but also it will provide livelihoods to so many other people. So that ecosystem, it's already on. The IITs are actually playing a major role there by driving this innovative ecosystem. But all of us, all the young students these days must keep this in mind, that those who can, please try to translate your ideas into real products so that it can reach the masses. That's one thing which I try to convey at every meeting of this with the students that I have. Keep that as your career options. So the other thing is, of course, AI has done so many things. It's going everywhere. You have to use AI. But again, it has proved how insignificant, not AI, but nature is so powerful, nothing works in front of it. We have seen the remote sensing images which we are seeing. I mean, the universe is so big. There is one minuscule virus brought all of us down to our knees. So it is not just computerization, digitalization, or artificial intelligence. As human beings, we need to connect with each other. And that is also very important for the young students to keep in mind, that more and more we are connected digitally, the more we are becoming isolated individually. That is where we have a lot of problems in the society which we have to deal with. We have to first acknowledge the young students, young men and women, we have to acknowledge that yes, there is this problem and we have to work to overcome that. I have seen even my son and his friends sitting down, 5 young friends, young men sitting, each busy on their mobile. So that is something we have to, they are not talking. That talking is so important. We are talking with ChatGPT. So just to conclude now, before coming here, I had this great urge to go to ChatGPT to create a lecture for me, okay, that I could deliver here today. But I resisted that urge. I resisted that urge because I think even now, the digitally generated text is too much of brain, too little heart. So that is where I think we have to protect that heart. We have to protect that empathy. That is where I think we have to protect the human race. Otherwise, it's all machines, and if machines just take over, it is a sorry state of affairs for us. So with those few words, I thank all of you once again for for having invited me here, and I congratulate Andhra University. It has such a great legacy, and I wish it the very best in its future endeavors. I congratulate our the Vice Chancellor here so that he can take this university to greater heights, and all the students and staff members here. A happy Teachers' Day to all of you once again. Thank you very much.
Thank you, ma'am. You are very inspiring. On the occasion of Teachers' Day, let us all felicitate the great teachers who are here. I request our Honorable Chief Guest, along with our Honorable Vice Chancellor and Dr. C.H. Mohan Rao Garu, to felicitate the teachers who are here. Professor B.S. Murthy Garu, Director, IIT Hyderabad. Professor D.N. Reddy Garu, on the occasion of Teachers' Day, the next teacher who is being felicitated. On the occasion of Teachers' Day, the next teacher felicitated is Professor D.N. Reddy Garu, who is the former Vice Chancellor, JNTU Hyderabad. Sir, it's an honor for us to felicitate you. Next. The next teacher to be felicitated is Professor C.S.R.K. Prasad, Honorable Vice Chancellor. We have distinguished speakers whom we are going to felicitate today. Dr. D. Raghunath Rao Garu, Founder Director, Homi Baba Cancer Hospital, Visakhapatnam. The next speaker to be felicitated is Professor G. Narahari Sastry, former Director, CSIR, NEIST, Jorhat, IIT Hyderabad. now request Dr. V.M. Chowdhury, Group Director, NRSC, to come onto the dais. We now felicitate Dr. Chowdhury. We now have the honor to felicitate Dr. V.M. Chowdhury, Group Director, NRSC. I now request the Chief Guest to felicitate the guests of honor, Dr. Mrutyunjay Mahapatragar. Now I request the Chief Guest to felicitate Dr. Prakash Chauhan, బందోపాధ్యాయ గారు. Ladies and gentlemen, it's time to felicitate our chief guest of today's function, Padma Shri Professor Sangamitra Bandyopadhyay.
On behalf of organizers and also from Academy for Science, Technology and Communication, I request our chairman and vice chairman to felicitate the Professor Rajsekhar Garu, Vice Chancellor, who is the man behind this whole activity, for his encouragement, inspiration, what I cannot express in words. I request Professor Dr. Mohan Garu and Dr. Raghunath Rao Garu to join.
I now request our Honorable Vice Chancellor to felicitate Dr. C.H. Mohan Rao Garu. Dr. C.H. Mohan Rao Garu, Chairman ASTs. I also request our Honorable Vice Chancellor to felicitate Narsimham Garu with Professor Narsimha Rao.
So thank you all for your kind patience, and once again thanks to all the dignitaries for kindly cooperating and bearing with us in spite of the delay. So now it's our privilege and honor to declare that National Remote Sensing Center, NRSC, Hyderabad, under the leadership of Dr. Prakash Chauhan, Director of NRSC, has kindly initiated two great MOUs with Andhra University. So the relation with NRSC and Andhra University is not new, and I am sure Dr. Prakash Chauhan would be summarizing in his remarks. So let me take the privilege to announce the first MOU. So this MOU is about NICE's Coastal Observation Research Laboratory between National Remote Sensing Center, ISRO, Department of Space, Government of India, Balanagar, Hyderabad, and Center for Studies on Bay of Bengal, Andhra University, Visakhapatnam. Under this MOU, the thrust areas of research comprises of potential fishing zone studies using satellite remote sensing data, ocean state forecast studies, integrated process response characteristics of coastal regions, modeling of coastal ecosystems, application of geospatial technologies in management of wetland ecosystems, mineral and chemical fingerprinting of beach places, algal blooms of east coast of India, air-sea fluxes of CO2, vis-a-vis impact of physical, biogeochemical process, etc. Needless to mention, capacity building and documentation. So under this MOU, NRSC will provide instruments for collection and measurement of pH, TA, DIC and all other related parameters. NRSC will provide orientation training on the equipment operation, onboard and data collection procedure to the project personnel involved in this project. Coordinate the data collection, validation of the data, provide logistics for analysis of data. NRSC will also provide funds to CS BOB as mentioned in this MOU, etc. So may I request all the dignitaries, representatives of NRSC who are instrumental to kindly come on to the dais, please. And also on behalf of Andhra University, may I request Dr. Ramarao, Dr. Sailaja, and Principal, College of Science and Technology, Professor M.R. Raju, please. So I am very glad to announce that under this MOU, NRSC is supporting quantum of 1.58 crores. So may I request Dr. Prakash Chauhan ji to please honor us and proceed for the MOU signing, and initial remarks from Dr. Prakash Chauhan ji, please.
Okay. Thank you, Professor Rajshekhar ji, Honorable Vice Chancellor, for your remarks about the two very important MOUs which National Remote Sensing Center, Department of Space, ISRO is going to have with Andhra University today. He just gave the brief outlines of these two MOUs. Let me tell you at this moment that, as he was mentioning, the relationship between Andhra University and Department of Space, NRSC, is not new. In fact, many of you may be knowing Professor V.L. Dikshitulu, the former director of NRSC and a very distinguished professor from Indian Institute of Science who came on deputation. You know, in 1995, India got its first United Nations regional center called Center for Space Science and Technology Education in Asia and Pacific, CSST-AP. And this center is supposed to do capacity building in the broad field of geoinformatics, remote sensing, satellite navigation, satellite communication, space science, and atmospheric sciences. And there are multiple programs which are running as on today also last 30 years. And these programs runs at different ISRO centers. So all the participants in this program, they come from the Asia Pacific countries, and they require to be given degrees and diplomas for PG diploma as well as MTech degrees. So Andhra University came forward at that time to provide degrees to these students, and we had a broader MOU. And let me tell you that since last 30 years, this collaboration is going on. So it has an international footprint. More than 4,000 students have got benefited from this program, not only in India, but entire Central Asia and the Asia Pacific region. That's the kind of work which is happening since last 3 decades between Department of Space and after that, you also must have heard another constituent institution, Indian Institute of Remote Sensing, IARS Dehradun, which also runs MTech program and PG diploma programs for Indian students at Dehradun. That institute also provides degrees of Master of Technology with Geoengineering Department of Andhra University. So that collaboration is also very active. Afterwards, with the Meteorology and Oceanography Department and Geophysics Department, we had a lot of collaboration in projects related to oceanography, coastal mapping, mapping the water color as well as water quality. But of course, of late there was a lull. So we thought that we will revive our activities, and now in that context, NRSC is going to set up a coastal observatory here in Andhra University. And as Professor told, we are going to set up a suite of instrumentation to make measurements on various aspects of optical remote sensing, including data collection on the biooptical properties in the coastal areas, water quality, and of course various process studies like algal bloom and the sediment dynamics, etc., etc. For that, around 1.58 crore worth of instruments will be procured, is being procured by ISRO and NRSC and going to be installed, and this will be utilized by the students of the Andhra University of this department to do analysis, and it will also be useful for their completion of their PhDs and their Master's of Technology or MSc thesis. So this will go in a big way in terms of developing this science. Meteorology and atmospheric science of Andhra University has produced giants as you have heard in the morning. And I'm sure that the next generation will get benefited with this. Second MOU is a broader MOU for, capacity building. See, we talked in the morning about the big things which are happening in space sector, but we need trained manpower. And trained manpower has to come from universities. And for that matter, NRSC will collaborate with the Andhra University for providing short-term, medium-term opportunities for the students of Andhra University to come to Hyderabad, or we can also organize programs of training and capacity building in broad field of geoinformatics along with Andhra University students and faculty members. So that's all from us, and I think now we will proceed for the signing ceremony. Thank you.
So thank you very much, Dr. Chauhan ji. So the second one I did not mention loud and clear. So just before we exchange the second one, it's a capacity building and collaborative research in remote sensing and GIS technologies between Andhra University and NRSC. So under this, to offer student projects for BE, MTech, PhD students, to facilitate students of Andhra University for industrial visit to NRSC, to provide research opportunities at NRSC campus for AU PhD students, organize Antarctica live interaction at AU during important events, and to collaborate with AU joint projects. And equally, Andhra University has to reciprocate with the various outreach activities, etc. And may I request the coordinators who are also actively engaged. So, Dr. Professor Wazir Muhammad, then Professor Sunita and Professor Dr. Anand Gajpati Raju, if they are here, please. And on behalf of NRSC, we have with us Director Dr. Prakash Chauhan, and Dr. K. Chandrasekhar and Dr. B.M. Chaudhary. So now over to exchange. And signatories, G.S. Rao is signatories, and the coordinator Dr. Nagamani is also there. Thank you.
I now request yes, sir.
So I forgot to mention one of the major force behind this initiative today is Professor Rajendra Prasad ji, one of the veteran professor of Andhra University. Today, unfortunately, he is not here, but because of his persuasion and he is one of the doyen of Andhra University in the field of geophysics meteorology. So let us give a big round of clap for him so that this day we could see this thing. Thank you.
Thank you, sir. Now I invite our registrar, Professor K. Rambabu Garu, to propose the formal vote of thanks.
Now it is our turn. We would like to felicitate our Honorable Vice Chancellor of Andhra University. This is the Chandrayaan model lander, which is we should have a Lord. I think registrar also will get one more. Rocket is there.
Respected dignitaries on the dais and off the dais, good afternoon to you all. It is my privilege and honor to propose vote of thanks at the conclusion of the Science Conclave on the Science and Technology Frontiers for Swarnandhra and Viksit Bharat 2047, organized as part of the Centenary celebrations of Andhra University. First and foremost, we extend our heartfelt gratitude to our chief guest, Padma Shri Professor Shangamitra Bandopachaya, Director, Indian Statistical Institute, Calcutta, for her gracious presence and inspiring inaugural address. We are deeply thankful to our guest of honor, Dr. Mrityunjaya Mahapatra, Director General, Indian Meteorological Department, for delivering the prestigious Padma Bhushan Dr. P. Koteshwaram Memorial Lecture. Dr. Prakash Chauhan, Director, National Remote Sensing Center, Hyderabad, for his distinguished lecture on the Indian Space Program and its societal impact. Our sincere appreciation also goes to the eminent speakers, Professor B.S. Murthy, Director, IIT Hyderabad, Dr. D. Raghunandan Rao, Founder, Director, Homi Baba Cancer Hospital, Visakhapatnam, Professor G. Narahari Shastri, IIT Hyderabad, Dr. V.M. Chowdhury, NRSC, ISRO. Your valuable insights enriched the spirit of this conclave. Special thanks to the NRSC for taking up Memoranda of Understanding with Andhra University. We extend warm thanks to the Academy for Science, Technology and Communication, Hyderabad, for partnering with Andhra University in organizing this event. I also wish to place on record our gratitude to the Vice Chancellor, Deans, Principals, Faculty members, students, staff, AAA members, and invited guests for their enthusiastic participation and constant encouragement. A very special acknowledgement goes to the press and media representatives for their wholehearted support in giving wide coverage to this event and helping us carry the message of science and innovation to the society as large. My sincere thanks to the organizing committee, volunteers, and technical teams for their tireless efforts behind the scenes, which made this conclave a success. Finally, to all our distinguished participants and delegates, thank you for your presence and active engagement, which added immense value to today's program. On behalf of Andhra University, I once again extend my deep gratitude to everyone who made this conclave a memorable success. Thank you, one and all.
Ladies and gentlemen, let's all stand up for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
I request all the faculty of Engineering College, Andhra University, dignitaries, principals to join us for lunch at Sagarika. For the rest, the lunch is organized here near the convention center. I request everybody to come back here, assemble here sharp at 2 o'clock.